That's great, huh? It's very cute. Good evening, y'all. Welcome back to another Sunday night on the workbench with the Demilights. Doing some more things. Notice, oh, look what a feature. You didn't think this was a feature. Look how they're not catching fire. Look how they're not burning down. Look how they're working. That's so exciting. Yeah, Thomas, you got it just right. Yeah, that's like, I didn't think that would be like the key feature of this version, but the not catching fire part turns out to be pretty key, as it turns out, which is great. Hey, Cookie, good to see you again. Yeah, version 0.94 turns out is a keeper. I think it's looking quite good. Yeah, I mean, in the sense that it works. I also am still, I think I raved on this last time, but like having these things on Phoenix connectors is just absolutely tops. Like, you know, so full disclosure, if I seem a little extra goofy tonight, I took what we call in our household disaster nap today, which is a nap you don't mean to take and causes the whole rest of your day schedule to be a disaster. So I'm just a little bit loopy still. So I was rushing around here, I was trying to get these things turned on, and I had put weird sort of experimental programming on them, so I was trying to take that off. But like, in comparison to version 0.91 that had that 0.1 inch headers, the ability to be like, oh, this light, I'm not sure what's going on in there, well, I'll just unplug the thing, and I can work on it, and move it around, and plug it in. Oh, and now it's done? Okay, cool, plug it back in. It's back online. So, yeah, I'm super thrilled about, well, I'm super thrilled about the Phoenix connectors as like a thing going forward. I'm not super thrilled about these two units in particular. These are actually the two 0.93 units that we built last time that we then killed, or that the control boards fried on it, and it turns out that doing that damaged the servos pretty badly, and the soldering on the light on this one is also pretty junked. So I was hoping I could just swap the control boards out in these, and I would have two working 0.93 units. But right now they're just little decorative glowy boys, but that's okay. Because that's not going to be the theme of what we work on tonight. We're going to work on more if I put my big face up here, we're going to work on more communication related stuff. Oh, very good. That's some good knowing how things work. So we'll get to that in a second. These are working just fine. The communications that I'm talking about actually will be both on the DMX side and on the programming the boards side, which is still not quite as easy as I would like for a project that I want others to be able to go out and build. So we're going to do just a little bit of experimenting tonight with the ATmega 32.8 and see if we can come up with a better way to program these boards than over the ICSP header. We're going to look a little bit at RDM, because the big project that I've been working on this week, this is great. I was like, oh, I want to show you the board that's off camera up here, but it's plugged into all these things. No problem. Can just unplug the thing. Bring it back over here. Yeah, that's something I wasn't able to do until like just very, very recently. So that, I don't know. It's still enjoyable to me to be able to like just plug and unplug things. So we've caught up to the marvels of modern technology. So this is I'll zoom in a little here. This is just another version 094 board that I've been playing with this week. I've actually got the ICSP programmer plugged into it. You can tell I just smashed an LED star in there to do some testing with, and I put a bit of wire on the output. I've been using this as my test bed for RDM recently, and let's see, I don't know if I destroyed this adapter that I was using with my logic analyzer. I don't think I didn't mean to. Oh yeah, so like, here we go. Bring this over here. Getting a little bit ahead of myself, but I'm just so jazzed about how easy having actual connectors on these boards makes things. Let's squish some of these things out of the way. I guess I don't need 12-volt power running hither and yon if the lights aren't plugged in. So this is the control board that I've been testing with. It's I get ahead of myself when I'm excited about things. Chris is not wrong. That's been true since forever. So I'm working on this board, right? This is just a version 0.94 control board that I've been using as a controller, actually, as a DMX sending device, just to, send DMX out into the lights. And I wasn't doing exactly what I thought it should do with respect to the RDM communication library that I'm working on. So I was like, oh, I'd really like to be able to plug in my logic analyzer to this. But where am I gonna probe? It doesn't have great oh, I know. I'll just unplug that cable, right, that I've been using to plug into the lights. Get that out of here. I just took 3 little DuPont wires and shoved them into the proper ports in another Phoenix connector. That's the little janky, Amazonian logic analyzer. I plug that in, right? And as long as I give it power, in this case I've been doing it over just the ICSP port because I'm reprogramming this thing all the time, right? Now I've got my logic analyzer plugged in, and when I'm done and I want to test it on the lights again, I just bring the other cable over and I plug it back in. So that's I don't know, that's still a new feature to me, and I'm super jazzed about it because it really does. It's paying dividends on the workbench side of things as much as I think it will ultimately for usability. So yeah, Chris, it's really fun. It feels really good after monkeying around with those little 0.1 inch headers for so long. I'm really jazzed about that. So anyway, just exciting. Getting a little ahead of myself. So what have I forgotten in my rush? Oh yes, tonight's beer of choice. And again, I no pressure to drink anything. This is just something that I enjoy. If you're not drinking a beer or something tasty, I hope you're hydrating out there. But tonight I am drinking an unfiltered wheat beer from Boulevard Brewing Company. This is actually the beer for tonight's beer advent calendar that we're doing, my wife and I, over the course of December, which is good. Waking up from a disaster nap just seemed like having a whole... Yeah, that can is empty because the beer is in a glass. The beer's in this glass. It's about to be in this glass. Dumb. Yeah, having a whole tall boy or even a can of beer at this point just seemed like a little bit much. So a nice lightweight wheat beer seemed good. Very good. Yes, that was my wife's suggestion. She's very smart. She says hi, by the way. I don't know if you can... I don't think it's focused on the whiteboard back here. The whiteboard, which I guess, Chris, you spotted this earlier, I reorganized the office/workshop, which is feeling great. I got a real bug in my bonnet the other day. I was reorganizing some of the parts related to the Demilight project because they're in I think 9 or 10 different bins, and some were up on those shelves there, and some are up on the shelves that are behind the camera, and some are in the shelves over here. Mary, Nate says hi. I think she's on another Zoom, but I'll let her know. She'll probably bust in at some point on these casual weeks. She likes to. So yeah, so I basically, the big thing was rotating this shelf out of the way, to give myself another wall to work with here. And that's not a done deal by any means. Like, that is just, you know, begging to be filled with storage of some kind. And I've just got the whiteboard and the clock and a few things up there now. I also, this will probably be a disaster for lighting, but I freed up basically this whole wall space, which is right next to my work area here, and right next to where the 3D printer normally lives, although it's now up on the shelf there. The new 3D printer that's coming in January is going to go on this shelf, and the old one's going to live up there. So now I have a whole area over here where I'm planning to stock up with, like, now that like my workflow is streamlined a little bit, like I really want to have, you know, these 4 square feet of space right off my right hand be, you know, I want to have a place to hang my soldering vise and a place to hang my desoldering gun and things like that. Just so, like, it's all relatively within reach, but not living on the workbench itself, because things are getting a little bit cramped down here. Chris notes the clock is wrong. Yeah, I need to. The clock doesn't keep good time anyway, so I took the battery out of it. So it's at least says a consistent time, if not the correct time. Maybe that would be a fun. That would be a good project. I think it just needs some oiling in the little spinny do, the little center thing. Yeah, I made that actually back in undergrad. I've had that clock for over a decade now, and it's just hanging up there. Hooking our Arduino up. That's what I would do with this clock, which you can't really see hiding over there. That clock is 3 DC voltmeters, one for hours, one for minutes, one for seconds. But I'll put that up when it's actually working, and I didn't do a particularly good job with the mechanics of that one, so it's falling apart a little bit. Anyway, so that's been my big project really. That and RDM have been the big stuff. And the RDM is not working great. So maybe here, I need a little hydration, I need a little beer, and I am going to dive into, I'm going to share with you where we are so far on the RDM project and the trials that I'm having. I not think what I think we're going to work on for most of the night, just because, like, it's really just like code debugging at this point. And as those of you who have been in the Python side of things, especially last week, that's a challenging thing to make visually interesting on a streaming format, I feel like. But I think sharing with you what's going on will be fun, and then we'll dive into. I have some stuff to do some hardware experiments for other ways to communicate with the Demilight boards that I think will be what I want to work on tonight, because I really have not started that part of the experimentation at all. So it's one of those things that it might work the way that it's kind of formulating in my brain. It probably won't catch fire, probably. Not impossible, but we shall see. So a quick pause for hydration and questions. And then we'll talk about RDM. Very tasty, very unfiltered and weedy and very good. I said I was gonna hydrate. I have liquids scattered all around the workbench, which is probably not the best. Yeah, let's talk about RDM a little bit here. So I thought I thought I had loaded it up, but I haven't. No, I still have my Advent of Code page up here. This is the other thing that's been keeping me busy this week, is these Advent of Code challenges. It's like a coding challenge for every day in December, and they get harder and harder as we go along. So, you know, for example, today's it gives you a little story system, a little flavor text, and then gives you some kind of programming challenge. And basically today's was find the smallest number such that in your puzzle input, which is different for everybody, or different, there's 100 different ones of them. So if this is my puzzle input, 17xxx, you probably can't see that. Yeah, 17xxxxx. Find a number that is a multiple of 17 that is 1, 2, 3, 4, 5, 6, 7 more than a multiple of 41, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 more than a multiple of 983, and so on for all of your input numbers, which turns out to be a non-trivial problem to solve. And for my problem set, at least, the answer was well over 100 trillion, was this giant number here. So, in any case, that's also been keeping me busy this week. Adventofcode.com, if you're interested in playing with that. I think it's a great way to practice some programming. But that's not what we were going to talk about. We were going to talk about RDM. So let's close all the windows. Let's hide the desktop icons. Not because I care, but just because isn't this nice and clean? Oh, I guess I've closed the streaming software and the chat, so I can't see anything. Good streaming, Jeff. A+. Thomas says, what do you say, Thomas? RDM can be funky. Tried implementing it on my mover. It was just a mess. Ended up not doing it. Yeah, it's definitely like I have shied away from it till now, just because it's troublesome. But given how far along things are, I feel like, if we were, yes, Chris, you were gone for a second, but now you're back. At the point where I want to have like several of these, hooked up to a system and hooked up to a transmitter, I feel like RDM is the cleanest way to like address and configure them if you have the hardware to do it. And actually that's going to lead me to another part of this project, and I'll show you in a second here, which is making a low-cost RDM configurator. Because right now, the best way to configure RDM devices, in my opinion, is to have like an ETC Net3 gateway and use Net3 configurator on things, which is great, but those Net3 nodes are like $1,000 a piece or like $700 a piece used, which is not a great system. Dave was never here. Oh, Dave's a ghost, as always. So what I have been working on. Where is the computer? There it is. So let's pull up what's going to be the best way to show this. Let's pull up VS Code, which is my IDE of choice, and I will open up the code base that I'm working on. So the DMX library that I use for all of these, like, ATmega 328 projects, and is the Conceptonetics library from who? It's in the README here. From W.A. van der Meren is his name. He developed this originally. It's licensed under the GNU General Public License V2, I want to say, or no, it's lesser GPL, which is great. I'm not an IP lawyer, and I know this is too small to read. There's nothing interesting to see on the screen yet. The LGPL is a really cool library license because it basically says, from my understanding, and I'm not an IP lawyer, that if you publish a piece of code under the GNU public license, my understanding of it from reading the internet and not being a lawyer is if you use that code in your code base, in your software, then you are required to make your entire code base, your entire software, available under those same terms to the public, under the GPL yourself. The lesser public license, the LGPL, basically says you can use this software in your code base. And if you make any modifications to that core, the code that you've inherited, you have to publish those, but you aren't required to publish your own code that's relying on that library. So, for example, there's nothing terribly fancy about my code, so I'm going to put it all up. But if you were, basically any changes I make to the Conceptonetics library or any fork of it I make, I have to publish. But any sort of additional code on top of that, I'm not necessarily required to publish. So it's a very permissive license for an open software license, which is great. Thomas says, you don't want to have a multi-$100 to $1,000 lighting console to program your $20 lights. Yeah, that's where I'm getting stuck, right? It's like I don't even have one to test with. There was an auction out in the west suburbs of Illinois a couple months ago that I think Palmer, I don't know if Palmer and Katie are here tonight, Palmer turned me on to, and it had like Net 2 nodes for like $70 and Net 3 nodes for like a couple hundred, and I almost jumped at it, and then I decided, this was like mid-April or May when things were really hairy in the world, and I was like, that seems like a bad idea right now, and now I'm kicking myself because, of course, like that opportunity is gone. So when those pop up again, or if anyone's ever throwing away a Net 3 node, A, don't, but B, send it to me instead. So all this is a long way around of saying, so I have forked the Conceptonetics library and started making some improvements to it. Let me make the font size bigger here, because this just won't do. Let's do editor font size. I forget what we did for the Python class last week, but I think it was something closer to that. That seems a little bit more readable. Searching for my GoFundMe page, yeah. I think there's more meaningful causes in the world right now. I wonder if there's like a Go node me. Is there like a Go like, hey, looking for like 4 or 5 nodes just to get me through? That's unfair. There's lots of people on GoFundMe who actually need the help. I am fine. But I still think it's probably wise not to drop $1,000 on this device for the moment. So this is here. Let me. Oh, you know what's funny? So I am so used to. I use my little Stream Deck stream controller. Thanks again, Nate. To control VS Code when I'm in a programming mode. But of course, right now I'm using it to control streamy things. And so I'm just like, oh, I want to collapse everything. Oh, no, I can't collapse everything because when I press the button that's normally in the collapse all spot, it changes to this view. Of course, they're labeled, but like I'm just like my muscle memory is thrown off here. In any case, so if you want to check out, I should have put this link in the links. But all of this code, if you want to, maybe I can do it right now. Who cares? You guys are all pretty casual. We'll go to my GitHub, which now has a night mode. Thanks, GitHub. Not the Advent of Code repo. The JDMX repo is what I'm very, very egotistically calling my fork of the Conceptinetics library. It is maintaining all the functionality from Conceptinetics. It looks like there's no activity here, but that's mostly because it's all in this main branch that's synced to my local code base that I will merge in when it actually has some meaningful working changes to it. Right now, it just does everything that the Conceptinetics library does. So DMX receive, DMX transmit, RDM limited receive of messages. This is one of the reasons I'm interested to get my hands on an RDM capable device, is to do some testing of its built-in RDM functionality. Given what I've seen so far, I think it has some errors, but that would be, of course, a good thing to get working. And for those who are like, what the heck is RDM? We'll get there in a second, I swear. Probably should have gotten there 2 seconds ago, but here we are. What I am working on right now is RDM transmission. So the Conceptinetics code base came with a bunch of functionality for an RDM responder, so an endpoint device. So that's the code that would live on a light. I am working on extending this library to include an RDM controller. And my dream, well, I have like 17 dreams. Like this project is spiraling, bigger and bigger. But one of my dreams is, so I have the ability to build some cheap hardware that, sends DMX, receives RDM. I would love to have a little box that's just, it's either, it hooks up to the computer and with a really rudimentary interface allows for just sending of RDM configuration messages across a DMX path, or the device I'm imagining is, what am I saying? The device I'm imagining is, like a little box, a little pocket-sized, size of like, this is a bad analogy, but like a large vape with a 5-pin XLR female connector on one end, maybe a 4-digit 7-segment screen, and a clickable encoder. And all it's meant to do is you plug it into a DMX line, you send to discover all the to have it discover all the capable devices on the line, and then allow you to address them. And that's it, right? It doesn't do configuration. It doesn't do anything like that. It just has a discovery mode. It then lets you click the encoder through each of the lights in your string and say, yes, I want to address this one. That one should be, 62, and this one should be 74, and so on. And probably when you click through, then it runs the identify function on that light. And that's all. I'm imagining this from my time as a theater electrician. Would be really useful. So for those of you who I don't think I've ever told the full backstory of my career on here, but the short story is I was the master electrician at a mid-sized regional theater, then I was the master electrician at a large regional theater, and then just over a year ago I made the jump to, I'm now an exhibit engineer at a major Midwest science museum, which is really cool. They have me doing a lot of lighting stuff still anyway, but in our theater days, especially we built a new theater that opened in 2017 that had a bunch of LED lights in it, and for the first couple of productions we mounted there, we did the sort of old style thing of address every light, put a gaff tape label on it, and then have our electricians hang it. But pretty soon, because the whole space was Net 3 and everything was ACN anyway, we just said, hey, here's where it was a bunch of color source spots and color source pars were our main intelligent fixtures in inventory. You know, we had like 60 of each. We're like, hey, just, you know, get the right barrel in it, hang it anywhere, and then once everything's hung, we can go back from a console or a laptop and just say, okay, what's on Universe 8 up there on the balcony rail? Oh, okay, well, the first light there, that should be address 62, and that should be address 70. And it was faster and more accurate for us to address them from the console afterward, and honestly easier for the electricians, because they didn't have to worry about which light was which, and sort of do it all from the console anyway. So my mind goes to RDM as a configuration methodology really quickly, just because that's where my background comes from. But of course, as I say, like, it normally requires a pretty expensive setup to do. Chris says the RDM on concept has been in process for a while. Don't think much has happened over the past few years. Yeah, exactly, Chris. I don't think there's been any updates to the Concept and NX library that I've seen posted since like 2017, which is why I'm forking it, because I think it's time to continue some development there. So in theory, right now, if you were to download the JDMX library and install it, it would run exactly the same as the Concept and NX library. I'm just doing the developmental work sort of on top of that functionality. Dave says, can you tell us what regional theaters you're at? Yeah, sure. I was the assistant master electrician and then the master electrician at Looking Glass Theater, which is in downtown Chicago here. And then I guess my title was the lighting and projection supervisor. They snuck supervisor into my name, so it was clear that I was not union. At Chicago Shakespeare Theater, which is up in Chicago here on Navy Pier. We opened the Yard Theater, is that one that I mentioned that we were opening up. Yeah, but two really interesting reconfigurable spaces. And Chicago Shakes had, it's interesting, my, like, trying to read the chat and talk, like, reading and talking is like patting your tummy and rubbing your tummy and patting your head. Words are complicated. Matt Reinert says, Dave, that name doesn't ring a bell. But it's possible. I was only at Shakespeare from 2016 on, so relatively newbie as there. I was not there all that long in the grand scheme of things. Words are hard. Yeah, Thomas, it's true. Words are especially hard today. I think I like just like floating around in a sea of nap still, which is pretty fun. Talking is also hard. Coding is also hard. Doing all these hard things at the same time. But that's all right. So in any case, so just to give you a glimpse of where I'm at with the very beginnings of this RDM controller project, it will be, so let's take a little bit of a look at DMX data and RDM data, because I think that will be interesting. I mean, I'm sure many of y'all have seen it before, but I will show you the way that I'm looking at it currently. So let me open a program called Pulse View, which is a free program that interacts with logic analyzers. It's an inexpensive program, and this is an inexpensive logic analyzer, so it sometimes is a little bit buggy. But what I will do here while that's loading up is load up my test code. Let me zoom that in there. That I will re-upload to my RDM controller board at the moment, and I can just show you how RDM shows up on a DMX stream. In fact, here, let's pull up our DMX controller software. So I'm going to just make sure my ICSP header is plugged in. I'm going to upload this, which is the program that was running in the pre-stream little window there that was making the lights turn on and off. So it's just sending 512 channels of DMX down the line, right? Nothing terribly fancy. Some of them, the first few will have interesting values. The last ones will all be 0. So let's take a quick look at what that actually looks like on a DMX line. So let me pull up Pulse View here. I'm going to see if it will find, I know the interface is a little bit small, so when we have something actually interesting to look at after I configure it here, I'll see if we can embiggen it some. So I'm going to open up my logic analyzer, and I'm going to measure at, if there is a way to increase this. I can zoom in on the data, but it doesn't look like the interface zooms, which is a real shame. So I will not spend too much time here, because I imagine it's a little hard to see what's going on. But I'm going to have it capture 50 megasamples at 8 megahertz. And if I do a run here, I should see, that should be plenty of data. So you can see it's capturing DMX data coming in on my data line 1 and data line 2. And it's just on 1 and 2 because I have these probes coming off of the data plus and data minus lines of the DMX transmitter into channel 1 and channel 2 of the analyzer. So here, let me zoom that in a little bit more. Yes. And I know there is a way to make these taller Oh, trace height. Yeah, that's what I want. So we can see this a little bit better. Let's make these really quite big. How about 100 pixels tall each? And 100 pixels tall each. Pulse View, this program Pulse View that I'm using is actually a GUI that sits on top of a command line program called SIGROC. And SIGROC actually has some functionality that Pulse View does not. But one of the things that I like most about Pulse View, and I'm realizing now this will also probably have tiny font. Let's see here. Let me pull up a DMX data line. So Pulse View and SIGROC actually both have the ability to overlay a decoder on top of your data. So if you see here, each of these individual, between the breaks, which if you know anything about DMX, that's the sort of start and end of a DMX packet. So that's one DMX packet there, from 220 milliseconds to 226 milliseconds of my capture. If I enable my DMX decoder and I zoom in here, I can actually see it decode for me the individual data, the individual bits and bytes of that DMX data stream. So, and look how tiny that is. Let's see. So for example, here in this yellow, here's our start code, our 00 start code. Channel 1 has value hex 19 or decimal 25. Channel 2 has value decimal 90, decimal 90, decimal 29, and so on. And then we get far enough along, everything just zeroes out because everything past address, it looks like 18, I'm not sending any particular values to. So this is really handy for debugging DMX software because I don't have to sort of like, shove the DMX into a reception device to see what it is in theory putting out in DMX. I can actually look at the ones and zeros in a logic analyzer and figure that out. This logic analyzer, I think I mentioned, I bought this one on Amazon for I think $12. If you order them from overseas and don't mind slow shipping, they're like $5 or $6. A really super cool piece of technology to play with, because a real logic analyzer costs, $100 or $200 for a really decent hobbyist model, up to, like oscilloscopes, thousands and thousands of dollars if you want to. But for like $12, this is a really cool tool if you're for debugging digital things like digital protocols or Arduino-y things. So worth picking one of these up, I think. This would be a really cool stocking stuffer, I think, for the nerds that are you. Maybe buy one and put it in your own stocking. That would be my recommendation. So this has been really, really helpful as a tool for me because, this is I guess I should take a step back. From knowing most of the people who are in this chat and around these things, sort of vaguely, I think you all have a little bit of an exposure to theater and theater lighting, if not a lot of exposure to theater and theater lighting, but the 30-second gist of what is DMX, and then we'll talk about RDM, it is just a series of up to 512 8-bit values that flow down an RS-485 control line to control X. Usually dimmers or moving light parameters or something like that. So, and again, I know you can't see the text on here, so I'll read it to you. Here in this yellow block is the start code, is all zeros, and that tells us that the 512 bytes that follow are going to be what they call a dimmer control message, or really just a basic DMX message. If this is all zeros, this is standard DMX. If it's anything else, it's another message that another manufacturer has defined to mean something else. There are 512 alternate start code, or 256 alternate start codes that mean other things. Almost none of them are actually used in the wild. You basically just see this 0 start code, or what they call the null start code, and that just means that, like, hey, treat this, what comes after this, as data. But one of the alternate start codes that you do see is used for RDM. So let me do a quick modification here, and I will upload the RDM code, and we can have a quickie look at that. I'm going to plug this into data channel 2, and then I'm going to upload my test code here. And one of the big modifications that I figured out how to do yesterday is you can imagine that a device that is sending DMX down a line and a device that wants to send RDM down a data line sort of has to negotiate which of those states it is. Is it just vomiting out its DMX data as fast as it can, or when it gets to the end of a DMX packet, does it want to slip an RDM control packet in there? What the modification that I made to the code base just yesterday is I have the ability to have a device like this one should be now, if we're very lucky, that just sends an RDM message and then goes back to non-sending. So I don't have to have an active DMX stream to be able to just send an RDM configuration, which is really what I want. I just want to send some configuration messages, at least for now, when I'm troubleshooting. Let's see if this will run. Yeah, there we go. Let's get pin 2 up on the screen. I'm going to zoom back out, and let's recapture. Yeah, so these little blips are, you can probably see on the display here, on the little indicator, having the little built-in LED flash every time I send an RDM message. So about every half a second, it's vomiting out a message, and that message should be basically a set DMX address method. Oops, just knocking my audio interface over. I don't think that's terribly important though. From this source address to this broadcast address, and it should be setting a light at a specific destination address to the value 100. And when I say destination address, I guess it's important to understand that that is not the same as a DMX address. It's going to be the unique, 48-bit address that is associated permanently to a given physical device. In RDM land, every manufacturer who wants to make an RDM compatible device, a controller or a receiver, or a device which does both, you write to the ESTA who controls the RDM spec, essentially, and say, hey, I want to make things with RDM. Can I have a 16-bit number, please? They say, sure, your company is assigned a number. And I actually wrote to Carl at ESTA last week and got the hex number 20C2, which I think is 8,963 in decimal. So all of the RDM packets which come to, that are coming from a device that I make will forever, under the Demilight project at least, have the first 16 digits be hex 20C2. That's kind of cool to have like a little slice of the RDM infrastructure with my name on it. So in theory, my device is sending a message from this address to this address with various other parameters that mean set address. And what that looks like is a little, so you can tell here, one of the problems with the code, it has the decoders in SIGROC Pulse. You have a little bit of a hard time with telling when a frame starts and stops when there's not a continuous stream of DMX. It's not it's not something it really knows how to do. So, but here's our purple break again. Here's our yellow, our start code here. And though you can't see it, the start code for an RDM message, as opposed to DMX, is hex CC, and it is decoding that there. So that tells us that it's an RDM message, which is great. Then I have 011A, which are the RDM start code, the RDM start symbol and the RDM substart symbol. We basically get two more symbols just to like remind the controller that, hey, no, really, this is RDM. And then the next 6 bytes should be the address I'm sending from. So it should be this, what should it be? Or the destination, so it should be FFEEDDCCBBBAA. And I just picked this address because I thought it would be easy to see on the decoder and figure out like what byte was going where. So I should have basically double F, double E, double D, and so on. What I instead have is 00DDCCBBAA00. Not quite right. My source address is coming out right, 20C2 4321, 20C2 4321, like that works. So something is going on weird in like the destination sending address that I'm in the process of troubleshooting and learning exactly how this library that I've chosen to fork works. So good progress there, and like so it is sending something that looks very much like an RDM message. I know you can't say. I wish I'd figured out how to like zoom this in beforehand, but you know that's the point of casual stream, is it's casual. But this byte here is hex 64 or decimal 100, so that's the address that would be setting that light to if this worked, which is pretty great. And I can see a bunch of the other parts of this message, like this bit here, which is hex 30. That is the shorthand for the DMX set address method. So let's see. Let me see if I can find set DMX DMX set set address. Yeah, DMX start address. So F0 is our sub message. So I have 30 for set and F0 for DMX address, so that's working out in here. So all this to say, I'm close. I'm quite close in sending a valid RDM message from what is essentially an Arduino. Something is going on that's a little bit screwy that I don't understand yet, and as you can probably tell from like looking at that code base, the troubleshooting process of that would just be kind of staring at code together. So not really what I'm interested in doing, like with my face visible, like, because what's the point? So the primary challenge that I'm trying to solve with RDM, right, is how do we address these lights? Because as Thomas said earlier, like, it feels silly to ask people to have, you know, an RDM controller to address things, so I'm trying to develop an RDM controller for people. The way that I address these lights currently, which is sort of option 2, that also works, but is still like a little bit more than I want to have to, how do I put this? Because I'm not asking anybody to build these, but I get the sense that like people would enjoy building them. And so it's like, if I'm going to put this out there and sort of try and make it as usable as possible, what are some sort of like approachable, usable options? So what I am doing, which is fine and works quite well for me, is I am, of course, setting the address inside of the Arduino code and then basically re-uploading that code to the ATmega 328. Right? To do that, I am using an ISP programmer. This is one I got from Adafruit like a decade ago or so. They still make a very similar one, and SparkFun actually makes one that's quite similar to this too. They're not horribly expensive. They're like $20. And I really like having one of these because I do a lot of work, you know, on microcontrollers and on boards. But it's just like another thing you have to buy if you want to try this out. And I'd like to reduce the sort of barriers to entry as much as I can. There is a project that is called the Arduino as ISP, Arduino as in-circuit serial programmer sketch, that basically is supposed to turn an Arduino Uno into an ICSP programmer. Specifically in Uno, I think the Pro Mini is supposed to work, but anything like a Leonardo or a Pro Biker that have like a ATmega 32U4 on them, it's a different code base and it won't work. So basically, you upload a specific sketch to your Uno, and then you wire the Uno in a specific way to your board, and you use your Uno as a programmer for your external board. That works in theory, but I have found it to be a little bit buggy, especially programming things that are not in an Uno-like processor, things that are sort of derivative of the Pro Mini and other lines. It's just buggy, and it always kind of has been. So it's a really cool project. I really like it, but it's not super reliable. So I don't sort of feel great about putting that out there. Like the first time I tried to program these boards, I was like, oh great, let's see if this works with the Uno as ISP sketch. Spent like 2 hours monkeying around trying to figure out what was wrong with my board, and then I pulled out my old programmer, worked first time. So it's not a great option. So that's programming option number 2, is ask people to program their addresses directly into the controller using an ISP programmer or an Arduino as ISP or something like that, which this would be fine. The Arduino would be okay, but still it's just like a hair less approachable than it could be, if that makes sense. So that's one option. So the two options that I think are worth exploring and we'll take a look at tonight are basically, so here, I actually have one right here. So this board at its heart, right, when I was first developing it, actually this is one of the very early prototypes. This is as it were, before this was the Demilight project, this is Demilight version 0.2. Really, before I knew I wanted to use it as a tiny moving light. This is just a shield essentially for an Arduino Pro Mini with an Max 485 chip on it and a little switch, and it's just to basically use an Arduino as a DMX sending or receiving a device. You can tell that back in the day I used this exclusively for testing receive because it has still a 3-pin male connector on it. But this was my essential test bed for like figuring out how the DMX send and receive circuitry would work. And it worked by just plugging the Arduino Pro Mini directly into the top of it on these header pins. And a bunch of the past versions of the Demilight literally had this socket on them, and you just plugged it in Arduino Pro Mini. To program the Arduino Pro Mini, as opposed to, let's grab one. Oh, you guys get a tummy cam tonight. You've been good. me pull out my Arduinos and microcontrollers bin here. We'll pull out a Mega. We'll pull out an Uno. Was there anything else that's worth pulling out? Oh, I had a Pro Micro in here. I wonder if I can find it. It's an ESP32. That's not quite what I was looking for. If I can't find it real quick, it's not super germane, but is it this? No, that's a little touchscreen. That's cute. I'm gonna play with that at some point. No, it's mostly Pro Minis in here, because that is sort of my go-to kludging form factor, because they're really cheap. Like $4 from Micro Center, or like $1 if you buy them in bulk. So just to compare and contrast the Pro Mini here with the Arduino Uno, which if you've touched an Arduino at all, chances are you've touched one of these. And the way you program these, of course, is, it's very, very convenient. You take your USB-A cable and you just plug it into your computer and you can program it. And the way that that's happening is there is a chip on here, and in the original Uno, and I think still on these, let's see. So originally this was a chip, an FTDI chip from Max, I want to say, that was a USB to serial converter. And it would take the incoming messages from your USB device and also handle everything like, identifying to the computer that this is a USB device and what kind of messages you can send it and at what speed. Like, there's a fair amount that goes into the USB protocol, which is mostly above my head. But as he takes those messages and turns them into serial TX and RX that can go into your microcontroller and come out and sort of translate back and forth. The Pro Mini, part of what makes it so cheap, is that it doesn't have any of that USB to serial circuitry on it. It's basically just the processor, a reset button, a couple of passive components, a voltage regulator, and that's it. So to program this over USB, you need to introduce another piece of hardware that is your USB conversion software. So this is a little... I think of these as FTDI adapters. Not all of them have an FTDI branded chip on them, although a lot of them do. Let's see if this one does. Yeah, So you can see the FTDI logo there. So this is that converter chip that's just been off-boarded, literally, to sort of be separate from the actual Arduino device itself. I should say the Unos nowadays, as of R3, they don't actually, it's not an FTDI chip anymore. It's actually another microcontroller that has USB built in. That's the Atmel 16U2, but same idea. It's right, it's doing USB to serial conversion. That's basically it. So one of the ways that we save money by buying these Pro Minis is we just say, well, if this is going to, if my microcontroller is going to sit in a box most of the time and do something not USB related, right, I don't really need to have the USB control circuitry sitting there the whole time. So why don't we just separate it, and then when I want to program something, I can plug that in, plug it into my computer, right, power things up, program it, and then I can take this part away and just leave this little guy to do its thing, right? So getting back to the point, one of the ways that we could introduce a better way to program the Demilight control boards would be to replicate this, right? Instead of having our ICSP header exposed as the primary programming interface, we could have, I think if we did this, it would be exactly this pinout, because it's pretty common. Introduce a 6-pin straight header somewhere onto the board, and then you would need an external programming device, much like this one. Get that back over there. So to program set your program on your Demilight, you would come over with your programmer, plug this in, upload it, and take it off. That feels a little bit more better to me, just because this is such a common piece of hardware. I mean, you can get these at Micro Center or Fry's or Adafruit or Amazon, or like they're super dirt cheap, and they're good to have anyway if you're nerding out with Arduinos, because they're super versatile. So saying that you would need one of these, which you could get for super cheap and is not super specific, is I think a better option than asking people to suggest that they have one of these, for example. So that's sort of option 3 for addressing, right? So we've talked about it could be RDM, it could be an ICSP programmer, it could be an offboard FTDI programmer. The last option number 4, is that we incorporate some amount of this. I guess there's 5 options. Jesus. we could incorporate some amount of this circuitry onto the Demilight board, right? We basically incorporate a USB to serial converter of some kind onto the board, and then the Demilight boards would have a USB connection on them for programming, which would be pretty classy. The other classy thing about that is though these chips require at least like 10.5 volts to light, the servos and the microcontroller and the DMX side of things, of course, all run off of 5 volts. So if you were plugged in over USB, you could basically drive everything except the lights themselves with this chip. And I guess if you had a chip, I don't know that this will go, that the AL8860 driver will go down this low, but if you had like a 3.7 volt single, well, I'm getting ahead of myself. If you had a chip that had a forward voltage of less than 5 volts, you can in theory run that off of USB as well if you could provide enough power. And then my brain goes, well, what if you used not USB mini B, which these all are, what if you used USB-C? And you could use USB-C power delivery to your moving lights. That sounds super cool. That is beyond my scope at this point for sure, although it would be really classy. Like a little desk accessory that was a moving light that ran off of USB-C. Super into it. Super cool idea. A little bit beyond what I'm going to bite off, at least for the next version. So I feel like the place to, the fifth option, just to continue enumerating them, the fifth option would be to switch to a microprocessor that has USB capabilities built in. And that would be a pretty significant change in the hardware for me, right? We've been using the ATmega328 all this time because it is so easy to program and so versatile. We could go to, I mean, the ESP32 is not really the answer here. It's a lot of power, more than we need. It's got Wi-Fi and Bluetooth and all these fancy things. I mean, it would be cool. It would give us some really easy configuration options. My mind goes to something like an ATmega, like the 16U2 that's on here is actually a fairly capable processor in its own right and can be connected directly to a USB port. So we'd have to rewrite the DMX library and probably the servo control library, and it would be a whole thing. But then we could just hang a USB port off of the side of the microcontroller itself, and that's how we can configure it. So those are sort of the five options that are circling on the plate at the moment. What I'm going to work on tonight is, I forget what the numbers of the options were. The option where we try and make it so the Demilight can accept this connection. That's my impulse for like what I feel like I am capable of doing at this point, and what seems reasonable. I mean, I guess I'm curious about opinions about that as well, like if that seems like a viable method. But to my mind, I mean, I guess the most approachable option would be there is a USB to serial converter on the board and a USB port. That is probably the most approachable. It just starts to add cost is the only thing. And part of the reason I standardized on these Pro Minis so long ago is because keeping this circuitry separate really does reduce the cost of these by a pretty significant margin. There's something also delightful to me about the idea of going back to this solution, because all of the early, in fact, let me see if I can grab them. I don't know if I made my mic cable long enough here. Let's see, old Demilights. All of the old versions, right, that were programmed over that interface, let's find an older version here, yeah, had this slot in the side because that's where the Pro Mini would sit. And so I would, basically, that would be sitting down in there like that, and you would take your FTDI programmer, and if you wanted to reprogram something, you'd shove that in that slot and reprogram and then pull it out. And if we go back to a world in which we have this connector on the Demilight, although I probably would do it vertical, so you just stab it down in from the top, going back to that as a solution feels, I don't know, feels kind of full circle-y to me. So that's, I think, what we're going to pursue tonight and see what we can learn. So we're gonna do a little bit of circuit experimentation. I know it's been like almost an hour of me just like explaining what I might do and what I have been doing, but I really wanted to share sort of like the context for what's going to happen next. I guess before I dive into putting the safety glasses on and trying things, the only other thing really to share on this project is that with 0.94 not catching fire, I have been working on getting the parts files, the STLs, the Gerbers out into the world. So this is not public yet because there's still quite a bit left to do. But let me just pull up my page. So I've been working on a page again. Like I said, this is not live on the web. Don't go looking for it now. But getting the parts, the PCB files, the assembly instructions, the other sourcing instructions up onto jeff.glass/Demilight. So those who have been itching to try and build your own, those files will be up there soon. As you can probably tell if you've been hanging around tonight, like there is a lot that I still want to do with this project. So like, things will continue to evolve, but the parts work well enough, the boards work well enough that I think it's good enough that I could feel good about putting it out there and saying, hey, if you want to take a swing at this, here's everything I think you should know. Just know, and you're all here because you're nerds in a beautiful way. If you take it on, it will be a process, right? You will, ordering the PCBs, assembling the components, and testing. And if you do, I absolutely want to hear about it. So that'll be coming out. But as soon as I can kind of get around to like cleaning all that information up. But I'm excited to be putting that out there. I think that'll be a lot of fun. So let's do some experimentation here. So what I am thinking is this. Back in the midst of time when I built this board, which became the Demilight. You can see I wasn't calling it Demilight. This was the focus there, camera. There we go. Arduino Pro Mini DMX Shield version 0.2. That's what I was calling this. So this was the long ago progenitor of the Demilight project. This needed this switch on board, this enable program switch, for a very specific reason. And let me pull up Eagle, our PCB software. Gosh, I probably should, as that's booting, which will take a second. I'm going to close some of the other programs that are open on the computer here. It's going to start throwing up on me. No, don't save pulse view data. Don't need to have Python open, don't need our countdown timer anymore. Our RDM packet data I don't need. Let's see, close, yes, close that. Okay, where is Eagle? Here we go. Let me bring that over here where we can actually see it, and bring the chat back so I can see that. There we go. So let's get rid of that schematic, and we will get rid of bring the board over here. I want to go back in the mists of time and look at the board and schematic files for that old version of what I was still calling the DMX Shield, which I think is this. Yeah, this is it. Let's look at the board. So this is actually, oh man, this is even more modern. Oh, but this version still has this switch on it, which is really what I care about. So this is actually, I must have overwritten this particular version of the board here. So this was one of the original versions of the Demilight board. Wow, this really takes me back. So this still had the socket for the Pro Mini, DMX in here. Here's our Max chip that's doing DMX. And then it has this enable and program switch setting. And the reason for that, and so I'm saying this slowly because I was trying to think why exactly this is necessary. Oh yes, I know. So the typical way of programming an Arduino, right? Oh, and partly what makes an Arduino is its bootloader. It's a little piece of code, right, that permanently lives on the microcontroller and allows us to program it using the serial lines. So before you get your pre-purchased Arduino from the factory, as it were, that little program will already be living on your chip. And that little bit of programming, right, has to be burned in using the ISP header here. This is sort of the manufacturer of the chip, Atmel, thinks you should be programming your chip using this sort of direct programming method of the ISP. But that's, as we've seen, not a super, straightforward thing to do. So part of the cool development that the Arduino Foundation did back in the day is they said, cool, we'll put a little tiny piece of code on there using this method that will teach it how to accept a program from the serial port, because doing a USB to serial device is really easy. So a little program that helps us load more programs onto it. So we're using that serial connection to get code onto the Arduino. But we're also using the serial connection to send and receive DMX. So I just closed VS Code, but this would be a great time to have it open. The way that this concept.nx library works essentially is just in the like sending and receiving DMX frame, right? Is when it's time to send so let me back up a step here. A device that's constantly sending DMX data, like one of our little boards that's putting DMX data out, basically just needs to have byte after byte after byte after byte of information that it's spitting out down what is essentially a serial line, right? That's then going to be turned from a single-ended output to a double-ended output for RS-485 and pushed out over a DMX line. So what the library is doing is it's using a couple of interrupts that are built into the ATmega328, which basically say, it will throw an interrupt whenever the buffer of outgoing data is empty. So you can load up that data, I think with only 1 byte at a time, and it will put that out over its output serial line. And when it's empty, it says, I need some more data. Run some code, give me more data. So we're running this interrupt service routine here, this ISR, on the USART TX interrupt, and that's coded in another part of the code when we run enough data to transmit. And it keeps track of what state it's in. So are we sending the break between packets? Are we sending the start byte? Are we sending the data? And basically, so I'm sending frame, DMX slot 31, that goes out bit by bit by bit. The controller says, hey, I'm out of data. We run this interrupt. It says, okay, we're in the middle of transmitting data. I'm going to get the slot value for the next slot and put that into the buffer, and then we'll send that out and send that out and send that out. We're out of data again. I'll load the next byte and so on. And DMX and RDM work in the same way in this sense. Reception is also very similar when it receives a byte. If you're being a DMX receive device, then it calls this interrupt that says, hey, I've received a byte of data in my serial port. I don't know what I should do with it. And then it calls this bit of code automatically that processes it and does something for us. So we're constantly, if we're receiving or transmitting, we are constantly using this same serial functionality for DMX. So if I want to program the microcontroller using that same serial port, I basically need a way to interrupt the incoming DMX data so that I can successfully program the device. So if you look at this board layout here, actually it might be easier to see in the schematic depending on how clean I made it once upon a time. Yeah, okay, so here's our little terminals where we would have our DMX connector soldered to. That is, on this device, that is just those 3 little pairs of pads down here. And even back then, I made them pairs so you can, in theory, have an in and an out on the same device. I have never used that yet, but I think it's a good idea. Those go into and out of this is Max 481. It's actually a Max 485, same chip. And the receive and transmit data lines from that go toward our microcontroller through this switch. So TXO and RXI are pins that are directly connected to our header pins there and ultimately our Arduino. So by flipping this switch to the down position, I basically isolate the Arduino from this DMX receiver. Because you can imagine, right, if I had DMX coming in on this connector, it would be constantly trying to send serial data to the RX pin of this Arduino. So even if I started to try programming it over the serial port, the data would be all kinds of funked up and gargled because it's getting data from 2 different sources. So I put a switch in here that I basically switched to the programming setting that cuts that off, so the only data that the serial port on the Arduino sees is the data I mean to send it for programming purposes. So this is a long way of saying the whole night is every night is a long way of saying I think I can accomplish that same functionality using a transistor triggered by one of the control lines on these FTDI breakout boards, so that we don't need to flip a physical switch, that it will basically automatically flip that switch whenever we try to program something with this. Thomas says, probably should have done that, just decided not to plug in DMX in programming. Also very good. That's also a perfectly valid solution. That will also work. So I think what I'm going to try and learn is if this I'll admit kind of half-baked idea in my head of using some of the control lines on this programmer to enable and disable DMX output here if that's a viable idea. But first, I just want to confirm / explore what those control signals are when we're programming this. So we're gonna build up a little circuit and explore that together. Let me see here. I can reach. Might need to make my mic cable a little bit longer here. Part of the joy of this office reconfig, and honestly some long overdue cleaning, is that I can roll around it a little bit more easily. I don't have to constantly be unhooking myself from the technology to reach back over to the control shelf here. Let's see. There we go. So back under here is my big bin of breadboards. Let's grab a couple breadboards. Alrighty. So let's see here. So I think what I want to do is basically be able to plug in. I'll give myself a little bit more room here. Plug in the Pro Mini and the Programmer. But I want to plug in the programming interfaces of the two of them and then be able to either stick, honestly, maybe the analyzer or probably just some LEDs on here, just so I can see what each of the control lines is doing at each part of the programming. So what I'd like is to do that. I'll stick another header on here, and then we will try programming this with some indicator lights hooked up. So let me get these little, so the FTDI breakouts have an ICSP header on them as well, and I am constantly bending them over. And if they touch, of course, the programming doesn't go very well. So there's our Pro Mini. Let me grab my bin of headers here. Let's see. I don't think, I have a bunch of right angle header. I don't think it's going to go into the breadboard very well. Let's see here. So what I'm going to use, so this is just standard 0.1 inch header. What I want, so I want some of this, which is double long header, so we can go deep into the breadboard and into my socket here. Thought maybe I don't have much right angle header left. Should restock. Oh, here's a little bit. That might be nice just to give ourselves a little bit more working room. But I think if I stick this right angle header, let's see, 6. If I stick this in the board, yeah, it's not going particularly deep into the board, so it's not making great contact, so I don't think that's the answer. I think I'm going to want this guy. So we'll stick that down in there like that, and we'll stick that in there vertically like so. And first, I guess before we do anything else, I'm going to just try uploading a little sample program to this Pro Mini to A, make sure that this Pro Mini still works, and B, that I can actually program it with this configuration. So let's go back over to our, let's just get like a little blink and light test. Let's open from the examples tab in our IDE. We'll do basics, we'll do blink. This is just going to be a nice, easy program to upload. We'll need to plug the programmer back into our computer. The other big change that I made to the workbench, oh, there we go. The other big change that I made to the workbench in the past couple weeks is I went to a wireless keyboard and mouse. Chris has no right angle headers. Chris, you might have missed. I tried the right angle headers. They don't go deep enough into the breadboard for me to be confident about them making contact. So I've gone to just vertical. I mean, right angle deep would be nice, but I don't think I have any in stock. So COM-port 3 Pro or Pro Mini. Let's upload. Oop, problem uploading to board. Why? Here, before we do this on the board, let's do this just in physical reality. Here, let's make sure that's not the issue. Compiling, problem uploading to board. Oh no. Why are you problem uploading? Oh, here, maybe it's the logic analyzer being plugged in that's confusing it. If the logic analyzers they're really neat, they're really cheap, but they are not a fancy device. Yes, I have a new COM port here, COM 6. So sometimes I find that they do strange things. This is promising. Writing, reading, done. And we should have Blinky. Yeah, there we go. Blinky. There we go. Okay, so that's a good sign. So now let's do the same thing again, but with it hopefully plugged into our breadboard here. Just to make sure that this part works before we get too much further down. So we're uploading, we're programming. We get little flashies here, and we should still have blinky. There we go. Okay, so that's good. So now what I'd like to do is have some LED indicators for each of the control lines on this board. I guess there's a power line and a ground line that I don't care about, but the other control lines on here are, let's see if you can see them there. We'll focus, yeah. CTS and DTR are control lines to and from the microcontroller, and then we have TXD and RXD, TX from the device and RX from the device. So I'd love to just have indicators on each of those. So what I'm going to do, there's a little bonus tummy cam for you tummy cam enthusiasts. Thomas here. I think you started joining us in the last couple weeks. It's so much of my storage, like the little webcam here is hanging on some shelves where all of my storage is. So when I have to reach up and get something, y'all just get like, you know, a little view of my tum. Now that the weather's cold, it's not so bad. When we were in the hot summer months in the office here, I felt like I was just like giving everyone a real nice view of my midriff every time I had to go up here and grab something. So that's what tummy cam is. I realize that's not an entirely obvious term. So I think I got a new pack of 10K resistors here. Let's see, let me give myself a little bit more space. 470 ohms. These are 1K. What are you? Oh, 0.1 ohm. That'll come back in later. What are you? These are, I think, yeah, 10. Big pack of 10K. That's what I will use as my current limiting resistors for my LEDs. So let's pop this out here, just so we can see it. Ooh, actually, I have a second one here that I can just leave alongside as a key. Pull off 4 of our 10K resistors. And let's start with our data lines. So for each of these, let's see, my ground line is this bottom line down here. So what I think, so basically I'm going to tie an LED through from each of my data lines to ground. So let me grab a little bit of wire here. Let's grab it. I'm just grabbing everything tonight. Grab my flush cutters, grab a snip of bell wire. As always, I just use, I have a bunch of DuPont connectors, but for little breadboarding wire, 20 gauge bell wire is best. So just cut a little bit off of that. And we'll I'm just gonna bring this ground connection out a little further from this program just so I have a little bit of room to work with. And then I'm going to take my, ooh, you know what I have? So I 3D printed one of these. I think I've used this before on stream. This is a lead former. So you can create leads of, you know, various breadboard spacings. So if I figure out which one is right, I can use this to make these resistors nice and neat here. So let's see. So let's do transmit and receive first. And actually, maybe we'll put transmit and receive up here, and we'll put the indicator signals down here. That might be cleaner. So it's the second and third pins from the top. Full of holiday gift ideas today? Yeah, Chris, they do make like, you know, injection molded ones of these. Like this is obviously a 3D printed version, but you can certainly buy them. And I will confess I don't use it super often, so I don't feel like I have the sort of fluency with it that I wish I did to be able to go, oh, I'm going 7 spaces, whip, boop, bop. But that would be a very useful thing to practice. For those of you who watch Ben Eater's videos on YouTube, who makes sort of 8-bit computers on breadboards and does some really clean breadboarding. I'm always jealous of his breadboarding skills. Let's see. So this would be the point where it'd be good if I remembered which setting I used last time, because this will be one hole further down the breadboard, and so its leads would be just sort of slightly further spaced. But I didn't do that because I just don't remember to. I guess it will be the same size because those don't want to be in the same spot. So that's transmit. So that's receive. Okay, so those are plugged in. We'll plug an LED into each of those, and then we'll need to bring our ground line over to that point here. And actually, this is a good excuse to pull out. I can't remember if I showed this off. I think I did. The organization of my DuPont wires, which after so many years of just having them all in a box, I now have pin, socket in a nice carrier there. And that just makes breadboarding more pleasant, because now I need a pin-to-pin DuPont connector, and I can just whip one out of the box. So ground is going to go from there to there. All right, so now in theory, when we plug this in, we should be able to see those lights flash as we program the Arduino. Excuse me. So let's plug that back in. Interesting. Let's make sure. So I wasn't expecting one to come on there. I'm just going to double check the polarity of my LEDs. No, those are accurate. Interesting. Okay. So let's reprogram this guy and see what happens. Here, I can zoom you back in. We get a little better chance of seeing them. So upload that. Yeah, so we make it a little dimmer in here. You can see that flickering. It's pretty obvious in person, but I suspect on camera it's not so much. Get that flicker, done. And so basically the TX line flickers and the RX line on the Arduino flickers as it's receiving data mostly. Then the TX line flickers because it actually sends the program back to the computer to make sure that it's uploaded it properly, and then it's done. So that's great. So that's what I was hoping would happen. So let me unplug this and we'll get some indicators on the other two signal lines, which is what I'm mostly curious about. And we'll use some different colors for these. So we will use I have this, I suspect our friend and confidant Kenneth Finnegan is not with us tonight. He usually has opinions in the chat if he is, but this bag was a gift from him when he came back from Shenzhen, including these warning stickers, which I quite like. Non-professionals do not open. It's pretty good. So let's get those wired up. So the DTR and CTS, so those are the topmost here, and the second from the bottom is CTS. Okay, so let's do a little bit more lead forming here. My thought is that the DTR and CTS lines are used to, among other things, reset the Arduino so it knows it's ready to be programmed. And I'm thinking that depending on what they do over the course of a programming cycle, that I could use one or both of them to trigger a little transistor that would interrupt the flow of DMX to or from the device to allow me to program it. But that whole idea is contingent on these lines actually doing something. So this is going to be sort of my experiment to see if that is true. Yeah, Cookie, it's a super cool gauge. Trying to think if I've it's on. I got it from Thingiverse, so I'm sure you could find it again there. But let me see if I happened to link to it. Because I compiled a big old compendium of my tools that I was using about a year ago, and I certainly was using this. Here we go. So this is a big post, December. Wow, just over a year ago, December 1st, 2019. That was a time. So in my soldering right up here, what did I say? Solder, flux, soldering iron cleaner, Heiko, 3D printed device. I don't think I linked to it here. I might have printed it after I wrote this all up. Yeah, it looks like I did. Anyway, it's on Thingiverse. It's a breadboard gauge. So I'm sure you'll be able to find it there. Oh, the other thing, let's see. It's actually I have two versions of it. So this is a wire stripping gauge. So you strip a little bit off the end of your bell wire, you shove it down into that little hole, and then this tells you how long that wire should be. So I guess if you like this smallest size here on the bending gauge corresponds to that size there on the cutting gauge. So you cut your wire to that length, you bend it to that length, and it should just fit. I don't use this as much. I just sort of, I tend to just sort of eyeball it and get it pretty close, or I'll bend it over the bending gauge and then snip it. But they were from the same maker. This also has an IC lead straightener, which is kind of handy. But that's all. That's all tangential. Yeah, those are some helpful tools for sure. Thomas says, if I was gonna give one of those to someone as a gift, I would totally model it as a Christmas tree for Xmas points. Oh, heck yeah, that's awesome. Yeah, I would. That's a really cool idea. These just happen to be. I just happen to have this, like, you know, Kelly green filament in my printer the day I printed it, I suspect. But yeah, a little Christmas tree wire bender model would be super cool. Let's see, what is my, oh yeah, my control line is there. So this is my normal method of, like, figuring out which how long the lead should be. Is I cut one end off, I bend it over, I set it roughly in the hole it's going to go in. I line up my thumbnail with the hole it's going to be in on the other side, and then I bend it over my thumb, trim it flat, and then I usually just get lazy and use my flush cutters to do the wire stripping, and that works fine. Especially because my wire strippers are all fairly beat up and have, like, little round parts in them anyway. So that'll go in like so. And that'll be our DTR signal. Okay. So now, I guess I've made this ground a little longer than it needs to be, but that's okay. So yellow will be one of our indicators, and we should make ourselves a little legend so we know which color means what as we're trying to decipher how we might do this. I'm gonna move this ground line a little bit closer. Just gonna snip this smaller. Let's see here. I'll strip that back, and we'll run the ground line to that row of our breadboard. We'll put the yellow. And polarity matters, of course. Make sure that the anode is toward the signal. All right, so those are our two indicators there. So we should come through and label real quick which one is which. I'm just gonna grab. If I'm labeling things at work, I actually have, theater board labeling tape that I like because it doesn't leave any residue, but gaff will work for now. We'll use our little fine tip Sharpie here. So let's see. So this upper signal is, so this is DTR, and this yellow one here is CTS. Just so we can remember which is which. I don't think it's going to matter so much which is RX and which is TX on this side, because we won't really be interacting with those. But, well, if it does, we'll come back and label them. But for now, I think this will be fine. So now, when I plug this in, interesting. So the DTR line is high and CTS is low. Let's watch what happens when I come over here and I hit upload. DTR goes low. Oh, we're not uploading though. Interesting. Oh, I didn't put a current limiting resistor on this DTR line. Well, that can't be good for anybody. Wondering why I had this extra resistor floating around. Well, I wonder if that's still good. I guess we'll find out. Wonder if any of this setup is still good at this point. But I suppose I did say that there was a slight chance of fire. Now we're only playing with 5 volts and 20 milli. Yeah, Thomas. Yeah, there's a slight. Listen. I know what the people come here for. I know what this has become. For better, for worse. So let's see here. So let's re-put this yellow LED in. We'll put the red LED in. So okay. So hopefully. I guess I don't know for a fact that this red LED is not toast. Let's reset this guy. And honestly, that this Arduino is not toast. Yeah, hey, I'm looking over at the computer here. Oh, there we go. So we did right. So I missed what happened down here, but it did upload, so that's good. And we still have blinking? Yes, okay, good. Whew. All right, so once again, we'll kill that overhead light there. Just I think it'll make it a little bit easier to see the blinking lights down here. So when I upload, not seeing any change at all there, which is strange to me. So I'm just going to preemptively toss out that 2-cent LED and replace it with another one. That seems like a good bit of insurance. You can tell I use the red LEDs the most because this was like a pretty evenly mixed bag, and now there's no reds left. This is clearly a used LED, which I think is a bad idea to keep around. Let's pull that back out. Grab a new. What's with all the LEDs are so... I don't know why I was like, oh, this will be fine. I'll throw it back in my bag to use again. I mean, listen, I am at a point where throwing away an LED is a thing I will do. I have not always been there makerly or financially. So, like, that's not shade on anybody. I just, at this point, I'm more likely to have damaged something also. So it's not good for me to be holding on to these things. Did I mess up the grounding line? Oh, yes. Yes, I did. The ground is not in the right place. That's why none of these lights are turning on. Well, we can fix that. Let's see. That's right, I moved the ground line so these LEDs wouldn't be jumping across space there. And there's DTR, and there's ground. Okay, that makes more sense. Does that actually help? I think the auto exposure on the camera is actually fighting me more than this light is, now that I think about it. So let's upload that and see what happens here. Not upload. I'm just going to reset the programmer here. Let's see when we actually start uploading. No, not uploading. So something that I'm doing, something is not right. Something is quite wrong. So we got resistor to LED to ground. It's probably just a wiring issue. Something's wrong. Yes, there's a great disturbance in the force. Yes. I think I had a little wiring issue with where I put that LED there. Hopefully. All right. So, upload. DTR goes low, we're programming, and DTR goes high. So DTR goes low when we're actively programming. Okay, we can make use of that. So that's good. So now what? So let's get this set up with a simulation of a DMX line. I guess it could be an actual DMX line, but I don't want to. I don't know that I want to try and bodge a Max 485 onto this breadboard. So what I'm going to do is, let's see. I pull this off here. I might need to end up spanning over to the other half of my breadboard because we're already getting a little crowded. Oh, maybe I'll make use of these ground lines here. That'll clean this up a little bit. So what I'm thinking about now is how am I going to actually implement this cockamamie scheme I have of putting a transistor or two somewhere that interrupts the incoming DMX so that the programmer can talk directly to the serial control lines. So I'm going to need a little bit more board space to do it, so I'm just going to quickly clean this up by replacing this big hanging DuPont connector with just some little breadboard jumpers that I'm making here. You can, of course, buy packs pre-formed of all of these lengths. Let's figure out what is this. This would be, again, a good use for our forming gauge. Yeah, so that's a length 3 in gauge terms. So I can pop that down in here. And And I can pop another one down on this other side, and then we'll sort of be making use of this ground bus on our breadboard, which I think we'll like having for what comes next. So here, so I've got my wire stripped off. I'll put it in 3. I'll bend it over the other half of the gauge. I'll snip it. I actually leave it a little bit longer there. This would probably be a decent like shop infrastructure day thing, as well as I should just sit here and get a decent organizer and just make a bunch of these little breadboard jumpers of various sizes, because I use them enough that it would be it's probably worth having them pre-made. So let's see, how do I want to hook this up? This is actually going to be a little bit too short. I'm going to have to jump over something here. Strip that. Bend this down. We'll go ground, goes into ground. And then let's just double check that everything still works the way we think it does. Ground goes into ground. And upload. There we go. DTR goes low. We load. DTR goes high. Okay, great. So that is as expected. So I started this by saying I'm going to set up our simulated DMX data. And to do that, I think I wish I had right angle headers here, but I basically need a way for this to not be directly connected to the Arduino. I guess that's not necessarily true. I'm running out of pin space down on the breadboard there. Let me grab another couple DuPont connectors here. Here we are. A couple more pin-to-pin connectors. What I will do, because we won't ever be in well, I guess we might be in trans mode. Let's do this through some current limiting. Is that what I want? TX is an output. I don't want to overdrive the output. Let me get just a 1K resistor here. I'm basically going to tie the is this necessary? Maybe it is a 470. What I'm thinking through is I want to tie the transmit and receive lines through a current limiting resistor to, plus or minus 5 volts or ground to simulate the presence of what we might call malicious data on those data lines, so that our new solution can interrupt them, and we can prove that this actually works. But to do that, I think I am going to have to do a little bit of rewiring here. So let's move this directly over to the other side. We'll plug that in there, and then we'll say, okay, this is actually going to work out quite nicely. So where's our transmit and receive lines on this breadboard? And if I'm not making a ton of sense right now, I do apologize. I will make more sense when I have a plan. So now I just need to jump these 1, 2, 3, 4, 5 lines across my breadboard here. So this will take just a moment. Now is a good time for questions, either real questions or, as those of you who see me do the class days know, questions is just code for sip of beer. So what I'm going to do is basically jump these 5 relevant control lines: transmit, ground, TX, RX, and DTR, just from one side of the breadboard to the other. Oh, and I'll get to use my gauge again. I didn't think that was going to be such a star player this week, but here we are. So I'm not going to bother with CTS, which is second from the bottom here. I think CTS is actually maybe connected to ground on these little FTDI breakouts because it's unused. I feel like I've seen that in the schematic before. For those who haven't seen it, Thomas is another person who's been building little moving lights, which has been super cool. Thomas, I don't know if you know this, so I was reminded by Facebook just this week that the very first mini moving light in this size that I built was like exactly 3 years ago now. So I built it and I was like, oh, that's cool. And then I kind of left it aside, and it wasn't really until I saw some posts, and they may have been yours, my memory's not that good, on the subreddit, on the Tech Theater subreddit, that I was like, oh yeah, that project was cool, I should pick that up again. And I've sort of been going in a run ever since like late last year. So I don't remember if that was you, Thomas, but I really enjoy seeing other people making. There's so much really accessible technology out there that is not like there's an untapped world of possibilities for theater makers to use 3D printers and Arduinos to do cool stuff. So anyway, I'm excited to see other people out there doing it. It's an A+. And it's a lot of fun. So much of what when I was in theater full time, like we did a lot, and I know Chris has done some other some electronics-y things as well, some like PLC and Arduino and various things. I know you've put it to good use in the theater world, Chris. I'm always like more surprised. Like I don't know if there's ever been like any content on that line, you know, in a USITT kind of vein, like in a broader educational setting. But it's useful, it's cheap, and it works pretty well. And that's just I feel like that's a power combination for theater people. It's like, oh, it's good, it's cheap, and it's pretty fast. I think it's worth considering bringing some of that info out to folks. Let me grab a little more breadboard wire here. We'll snip some of this off. But all right, let's jump this guy. May 17th, 2019. That sounds about right. Yeah, I think pretty much, yeah, because I started this 2017 and I've been working on it since like early-ish last year. So yeah, I think that was you. I think I was like, oh, hey, this is cool. Hey, I had a project like that. Maybe I should pick that up again. So thanks, I guess is what I'm saying. You were definitely, you spurred off some cool interest. Chris says, there's been some content, on the USIT recently, hard to do an entire class, and yeah, that's fair. There is a lot to know. I guess it also, like, it's a lot easier if you have some fundamentals in, like, electricity, like, basics of electricity, and if you don't, yeah, it might be, that would be a lot. Maybe a little bit more of an intensive class. Okay, so those lines are jumped now. Before we try anything new and fancy, let's just make sure we can still program the Pro Mini. Plug that in. When we upload, we are thinking about it. We are uploading. We're good. Okay, so good. So now what I'm thinking is, if I take my TX and RX are lines 2 and 3 here, if I take, for example, my TX and RX lines and bias them to ground with a 470 ohm resistor, I'm hoping this fails. I'm hoping that's like, I can't program this. We'll see. It worked, damn. I guess I could tie them directly to ground. Let's see. I guess that's not ideal. What I'm afraid of is like going over current on some of my outputs here, but I think we'll be okay. I mean, the worst thing is I burned up one or the other of these, and I have lots more of each, or at least some more of each. So if I do smoke something, I mean, A, it will be it will be what everyone's been waiting for, and B, I can replace them. All right, so those are both tied directly to ground now. So now when I try and upload, nothing should happen. Yeah, can't sync, error uploaded. Okay, so this is going to represent our these connections here, these lines being tied to ground. That's going to represent our DMX signal getting in the way of actually programming something. So what I want is a circuit that basically disconnects that from the input lines. So how are we going to make that possible? Oh, Thomas, working on the Mark II again. Oh, very cool. Nice, got some slip rings. Ooh, yeah, that's cool. Some little commutators so those things can go 360. That's awesome. Yeah, I want to see that for sure. Yeah, certainly using these little hobby servos that are limited to doing a 180 is not the most bestest. Yeah, that's a super cool thing. Once when I was at Looking Glass, we ordered like a giant like AC slip ring for a chandelier prop that was also a circus implement that people swung around on, and we ordered it from like a big massive industrial vendor in China. And for years I got emails saying, "Hey, Mr. Glass, we hear you like industrial slip rings. Would you like to buy another $300 slip ring?" I did not. I'm good. I bought one. That's plenty. So how are we going to make this happen? So, what I want is essentially a non-inverting unity gain amplifier, that will turn off when DTR goes low. I need some scratch paper. Do I have anything close by? I do. Well, I have the back of my D&D character sheet, but that doesn't feel quite like the thing. I thought I had a little notebook in here that I could make use of. Where is my notebooks file? This is the problem with, if anyone's ever like cleaned up their workspace knows, it's like, oh, it's all clean and everything has a place. Now, what is that? What is the place that I picked for each of these things? All right, there we go. So let's think about what this circuit is going to look like. Make some room here. So I have, for example, I can zoom that in a little bit, I suppose. I have the RX line of my Arduino here, and I have my DMX signal coming in here. So so I could have an inverting amplifier, right? I could just use an NPN transistor. It'd be 5 volts. This would be our gate, probably with a resistor in there, and then ground. And that would be our inverting amplifier. Is a common emitter a common emitter amplifier is well, the common collector amplifier is inverting. Is a common emitter amplifier inverting? I may have said that backward. So let's think. So this would be an inverting amplifier, and the amplifier is just, because it's using a transistor, it's not going to actually amplify the signal. It's going to be 5 volts or 0. But so if we had DMX coming in here, we have our RX line on our Arduino there. Let's think about what would happen if we did it as a common collector amplifier. So we take the output from the emitter here. So let's think about this. So when the DMX line is low, the NPN is not conducting, and so this would be pulled to ground. I guess we'd have to have a resistor, a load resistor there, of course. When the DMX line is high, this is conducting, so that's pulled to 5 volts. So this could be a configuration that we use. Except the whole point was that I wanted an additional input. Ooh, Thomas is going to use stepper motors. Yeah, undecided on light source. The 100-watt white LED NeoPixels high-power RGBW chip. Yeah, all super fun options. I'm excited to see where this project goes, Thomas. The most of those 100-watt LED chips, I'm sure you've seen, are like running like 32 to 34 volts DC. So dimming or powering that might be a little bit of a challenge, but it would be super fun. NeoPixels would be super hot, right? Like that, and not hot in a good way, like hot as in sexy and not hot as in roasting. High power RGBW would also be super fun. Yeah, those are some super cool options. The what it makes me think of, and I know we're all over the place tonight, but what did you expect? What it makes me think of, I don't think I have my teardown picks anywhere accessible. But when I was at Shakespeare, we got the first US tour of Six, the musical, and they traveled with a bunch of we rented for their plot a bunch of these Ayrton Magic Dots, these super cute little, 12-inch fixtures, and this fancy feature about them is they spin 360 degrees continuously in both pan and tilt. So this little ball just sits and spins, and that's super fun. It's like a 60-watt RGBW. Yeah. Oh, here. Well, we don't need to watch the whole video, but just to give you a sense of how fun they are. They're super zippy, of course, too, because there's not a lot of weight in that head. So yeah, so you can do all kinds of fun wibbly effects when you have lots of them. Let's see if they can really get them going here. Yeah, and because they can spin 360, they do all kinds of fun things. I tore one of these down at one point because we had them, and why not? Basically, this head is, a big fat copper control board, a little single RGBW emitter chip, this big fat lens in the front, and then just a giant fan and heatsink. It's mostly heatsink and heat management in there, which makes sense. Like, that's what a bunch of these LED fixtures are really just all about, heat management. Yeah, imagine that. Yeah, they're super classy. Oh, you've made 150-watt flashlights before. Yeah, the driver is the weird thing. I feel like when you watch YouTube videos of people making those, the super high power flashlights, they often just do like voltage control, which is not, I think the best way to do it, but is workable. Yeah, the dimming would be a challenge. But hey, it's good to have a challenge in these projects, right? So the other thing we could do, he said, not really sure if it was a thing that could do, is pass this through some logic, right? We could put an AND gate in here, right? And that goes to our RX line, and this is our, I guess, the inverse of our control line. Right, so when, oh, that's not necessarily true. No. This is just our control line. So when DTR is low, this will always be low, and we feed this through a little current limiting resistor, and this is our RX input. So that when DTR goes low, there's no way for the DMX to get through. But when DTR goes high after we program it, then we can get the DMX signal into our device. So that's fine. We can do the same thing on the TX side, sort of in the opposite direction. And that seems fine. It seems like a little cumbersome to have a logic gate, like glue logic, on our board. The other thing we could potentially do, although it might require more board modifications, let's go back to our schematic here. I'm having a brainwave, because we get these RX and TX enable lines essentially on the Max 485 chip that allow you to basically switch what, is it in transmit mode or is it in receive mode? And you're meant to tie these to the same control line, because one of them is active high and one of them is active low. So if it's high, it's receiving. If it's low, it's transmitting. I've broken them up into two separate control lines, both in this old version and in the current version, although I think the pins are different, because I want the troubleshooting ability to have it be neither a transmitter nor a receiver at any given point. That might be a silly thing to do, but that's where we are currently. Let me get you there. But I'm wondering if we could use these lines, like if we were to pull the receive enable pin high. Oops. Although, yeah, so if the DMX is coming in, I guess I would like this same solution to work whether we are using these boards as a transmitter or a receiver. Because I've found it very useful to have a little board that can both, and I should say, a board that's very useful to have a board that can be both a receiver and a transmitter. And if these are going to be RDM-enabled devices, then they all are going to be receiving and transmitting. So I would want this board to, to pull the receive enable pin high when DTR goes low. And that should put this into a high impedance state, so it shouldn't be receiving anything. Will it be transmitting anything? No, as long, I guess it should cause the transmit enable, the data enable line to go low as well. That seems plausible to me. It does mean I'm going to have to bodge together a DMX receive setup on this board here, but that's not the worst thing. Because I think, I left the headers on this old device, so that should be workable. So we can plug that straight into a breadboard. I think this might be the way to go. Now we'll still need a couple of little transistors to get we're going to need one transistor to get the polarity right. And let me think about diode protection here, because what I don't want is, I don't want a situation, wow, using Sharpie on this pad was not the right call. Let me grab a pen. What I don't want is a situation where, for example, I have, what's our receive enable pin, D4, where I have D4 coming in here. I have my, and that's set to be, because we're receiving, let's say that's set to be low, and then I have my input from my DTR line, and that's high, and I'm trying to sink probably more current than I can take into the pin of my microcontroller, and that has the possibility of damaging it, which is not ideal. So let me think here. What the diodes would need to be to... No exciting fires, please? Gotta make up your mind, Thomas. For earlier, you were pro-fire. Now we're anti-fire. I mean, listen, I appreciate the concern. So let's see. So, let me think about this. If this is so the D4 line. Let me draw out the schematic of our. I guess I could do this in the schematic editor. It's a program designed to draw schematics. Let's save this just as a scratch copy. Save as, we're gonna call this DMX Mover Shield, diode, scratch. And I'm actually gonna, maybe I'll put this in a different folder entirely, just so we don't confuse it for something else. Maybe we'll put this in, let's just put it on the desktop right now. That's good practice, right? Fires in the workbench are fun. Something catching on fire while you're just trying to use it is another. Oh yeah, for sure. Yeah, fires for me, no fires for you. Yes, I'm on board with that. So, oops, let me see here. Let me move a couple things out of the way so we have a little bit more room to work with. Let's move these resistors here. Let's get them a little closer. Move this label out of the way, and we'll move this. Oops. Gonna move this clump of resistors out of the way. You can. This is why I was doing it on paper, because it's not terribly fast doing the schematic editor, but maybe it'll be just a little bit more cromulent. Ooh, not the diode command. I need the add command. So let's add a generic diode. How about a 1N4148? So let's think about, so this line needs to be, it is being pulled to ground by this pull down resistor. So that this line defaults to this device being a receiver. If we're not driving either of these lines, which maybe is no longer the right answer, right? If this is active low, maybe the right answer is that this is actually pulled high, so that both of them are deactivated by default. Let's think about the ramifications of that in a second here. But But let's see. Oh, but I don't want to tie it to 5 volts directly. I want to tie it through this resistor. That would be probably a better idea. I'll move this guy up, and we will route that. So now, by default, the receive enable line is pulled high, which is disabled because it's active low. The transmit enable line is pulled low, which is because it's active high, so neither of those are active. So oh, interesting. Is that enough? Because when we reset the microcontroller, these two lines, D2 and D4, should go to a high impedance state. So we should disable transmit and receive on reset. That's interesting. Maybe that's the only change we need. So I guess, well, I guess not, because we're going to need still to attach to our TX and RX lines, although if they're both disabled, that should be fine. So that would end up looking like, I'm a little bit rambling here, so, right, so the whole point is we get rid of that switch, and we would have a connection point in here, and I'll just add it as a little 1-pin indicator. Pinhead, 1 pin. Yeah, so these two connection points, which of course, won't actually go on the circuit board, but these would represent a TX line from the FTDI and the RX line from the FTDI chip. Let's change that, RX, FTDI. That's interesting. Then we don't have to mess with the enable and disable pins at all. It's just that when they reset, these lines go to high impedance. I wonder, so maybe we need to check if that's true. If the 18 megas pins really do go to a high impedance state quickly enough to make this feasible. And if so, man, this would be a really great solution, because this would be a really easy change on the circuit board, right? This would be no additional components around the max, and I just would basically need to hook up the appropriate lines to TX and RX, and there'd be a little extra circuitry around the reset pin, because, and I'll show you in the schematic for one of these FTDI converters, if I had internet. FTDI schematic. Oh, I guess you know what it is? It's not in the FTDI converter, it's in the Pro Mini itself, because that's where essentially we're going to be aping. Let's open this in a new tab. So here's the schematic for the Pro Mini itself, and you can see up here there's some additional components on, here we go, on the reset line. So DTR goes through a 100 nanofarad capacitor. That line is pulled up to VCC by a 10K resistor, which I already have on the board. I think it's just permanently pulled up to 10K. Actually, I guess it's currently connected to the ICSP connector. And then you get this reset button that pulls it to ground. The purpose of this capacitor, as far as I understand, is when the DTR line goes from high to low, you basically get a single low pulse that pulses the reset line to ground, and then of course it charges right back up through this capacitor. So rather than holding that reset line low when we're programming, we just pulse it low. That resets the microcontroller and gets it ready for the bootloader to accept new code. So we would need to put this capacitor on the board. But let's do this experiment to see if these output lines do go to a high impedance state when we reset the Arduino, and if that's the case, I think this is a working solution. Maybe. So let's set that up on the workbench. Get this out of here. Because that, I mean, trying to minimize how many components are on this thing, I think is great for reliability, for cost reasons. So if we can do that, I am all about it. So let's set ourselves up here. with a... Oh, that's a tough breadboard. It just won't go in. Oh, well, that's there for all time now. Let's do a sort of minimum viable example here. So I'm just going to take a LED. Must be stale bread, Jesus. Killing me, Chris. So let's hook this up to... I guess I could probably have done this. Oh no, I need my digital inputs and outputs here, yes. So we'll hook this up to a random digital pin. This will be D5. And we'll have to do a couple different tests here. So we'll hook that up to D5 and we'll write some real quick code. We'll say... I think is that a decent text size to be seen? I think so. Let's see, const int pin, dpin equals 5, pin mode, dpin output, and then let's see, let's do in the setup here, digital write, dpin high. All right, so we'll plug that back into our programmer here, which I seem to have lost, which is very impressive because the desk is not that big. And I know there's two of them on here. It's buried under a lighting PCB. Plug that back in. All right, so there's that. And we will upload. It's going to make me save it as, I don't know what... put that on the desktop too. On Scorch. Yes, not gonna ever use that again. So we're uploading. We're thinking about uploading. Let's power cycle this guy. Oh, we're having some. We're having some COM port shenanigans again. But why? So I unplug that. It still has a COM port plugged in. I think. Maybe I will just restart my IDE. I really, at some point, should probably graduate to using a not the Arduino IDE, but it doesn't do much, and for my purposes, that's sometimes nice. Oh, lost my oh so good sketch, but thankfully I just put it on the desktop. Right? Didn't I? On Scratch, yes. Scratch. Let's see, COM port, I have COM. So I don't have it hooked up right now. It's still seeing a COM port. What? So some other device on my computer is pretending, oh, there we go. It's pretending to be a COM port. All right, let's try uploading that one more time. Compiling, oops, an error occurred. Let's reset the FTDI adapter, hit program, uploading, there we go, okay. So that should just, oh, of course, some of you may have spotted this error already. I've connected the LED pin to ground, but there's no ground there yet. So let's hook up ground. Put that just there. All right, LED turn on. Very good. So now what I want to see is, so when I hit upload again, I'm hoping that will turn off. Yes, so that goes to high impedance, and it does so before the data lines start activating, right? Here, let's see. Probably should have, if I was going to show you lighting things, I should have done this manually, but so high impedance, and actually you can see the little red light there blink. So it definitely is not staying in a high state. Chris says, can you upload from Visual Studio? In theory, you certainly can. I have never bothered to set it up because I'm lazy. But I really should. I have compiled code for Arduino in Visual Studio, and when I'm writing the JDMX library, I just include the Arduino C libraries into it, and then it lets me compile it just fine. As targeting an Atmel device, I just don't have the uploader, whatever it is, configured. So now that we know it doesn't stay high, let's make sure it doesn't stay low. So now, let's see. So I'll upload this code, and when I do, now we'll be syncing current into this pin. All right, so this LED should turn on again. Should turn on again? Did I get it backwards? Oh, of course, this should not be ground anymore. This should be 5 volts. VCC, yes. So now we're syncing a little bit of current in and turn that LED on. But now when I hit upload, turns off. Okay, so it is going to a high impedance state on reset, which is good. That's what it's supposed to do. So what does that mean for us? So looking here, thinking back to our schematic here. So if this were our schematic, which to be clear, it's not currently, if there was data coming in here, when we reset, pin D4 and D2 go to high impedance. So the data enable line be pulled low by this resistor, so we're no longer transmitting. The receive line gets pulled high by this resistor, so we're no longer receiving. So we should be able to just hook up our TX and RX lines more or less directly to our transmit pins, and we don't have to mech around with any of this like DTR CTS nonsense. I kind of like that. Just thinking, so because this is not the direction I thought we would go tonight, I haven't looked for it yet, but I think I have some some breadboard compatible Max 485 ICs here, and if I do, I'm almost positive I do. Can I find them? Do I know where they are? These are other good questions. But I think there's a decent chance we could do a proper test of this tonight. Going through all of the, I think I can show you what I'm going through. This was the project box from what I call the DMX FET project, or the DMX, what was the label? DMX IR. So this was a project I built for the Goodman that took in DMX into a little Arduino controlled board again, and blasted out IR control signals. They had a bunch of IR controlled, like those cheapy living room candles on their set that they wanted to turn off in a blackout. And so I built a little DMX controlled device for them with a 10 watt LED emitter on the end of it that blasted out on and off signals on DMX control, which that was a very fun project. And that actually, now that I think about it, I mean, I don't know what the state of that particular show is, but that show was running in mid-March. They certainly still have my device. It might even still be hanging on the balcony rail. I mean, at this point, it's all sort of academic, but just trying to think, where would these Max 485 chips, if I had them, be? I know I have opto ISOs here somewhere. I just saw them the other day. I have a thought. It's too far away for camera, so give me 30 seconds of the screensaver. I'll be right back. Chris, I don't even know quite what it would mean to have all the parts alphabetized, as it were. I mean, it sounds nice. This is the box where I think they're hiding. This box is just labeled "Sort Me," but I feel like this is dregs from old projects, including, I can show you as I piece through here. I think that's as far. Oh no, I can zoom out even further. Yeah, a couple of old SCSI floppy drives, some blower fans, some CR2032 batteries. But I feel like I have a little anti-static bag somewhere with at least 6N137s, which is a really common DIP opto ISO. And I thought that same bag had in it some either Max 485s. Ooh, these, yeah, 100 nanofarad caps. Those are always handy. Some 75 156s, which are another RS-485 converter chip. I'm not seeing... Oh, wait, hang on. No. I'm not seeing that bag in here, which I had this sense memory of a feeling like I did see it in here, which is good because it means I sorted it into somewhere. But it's bad in the sense of I don't know where it would be. Oh, maybe it would be, if I was very clever. I have a... Oops. Whoa. I have a bin back here in Demilight storage called Future Experiments. Maybe I would have thrown it into Future Experiments. It is the future, and this is an experiment, but no. No, I have just tiny stepper motors. These were, I meant to play with these at some point, but they're just to like, when I was playing, Chris, you were here, I think, for a live stream ages ago, where we looked at like that zoom lens option. Look how tiny those are. That you ended up using a giant, like, Weird Stuff warehouse stepper motor that I had on hand. But would it be in PCB components? That doesn't seem super likely, because I don't use these on the PCBs for the Demilight. If I cannot find these, this is not a super critical test, but it would be nice. I have shift registers in here. Optics just bend my brains, Thomas. Yeah, me too. We did. I think that stream is still archived here somewhere. You can go back and watch me just screwing around with like every kind of cheap lens and not really knowing what I'm doing. Had a good time, and ultimately we found something that was pretty cool and worked, but was not not something that I would ever claim to be any kind of an expert in. They weren't in PCB components. What other project box? Oh, did I maybe sort them into my components boxes? Maybe. I maybe can give you a view of this, come to think of it. Well, maybe it's this strange view. You can kind of just be staring into lights. Yeah, you're staring into lights. Although, maybe if I turn these lights off. I did order, because you can order cheap webcams again now. I did order another little cheapy webcam with the idea of experimenting with a more permanent setup for the view of the oscilloscope. You're just looking at my stomach now here. Here, you can look at this nice schematic while I sort through my parts bins. Because we've looked at the oscilloscope in past weeks, and actually I was messing with it right before this stream because I was having some unrelated issues. So maybe if I can squeeze another webcam onto this computer without it throwing up all over the place, I might try and do a semi-permanent setup there. I'm also, I mean, it's kind of exciting. I know I've been like sort of edging toward the idea of like doing a little mini light show with these moving lights since I started the project. But it feels like finally maybe I'm close. And so having some, I have to start kind of confronting the idea of like, what is that? Like, what does that actually look like? Where do I set it up? How many lights is it? What do they hang from? So I might need to figure out a new camera setup for that. That's not necessarily something I would set up on stream. Like, I'm thinking of that as like a filmed and synced to music kind of experience. But anyway, now I'm just rambling as I'm hunting through looking through bins, trying to think like, where would I have put a little bag of Optos if not in any of these project bins? DMX, Arduinos and micros. I really would have thought it would have been in one of these parts bins, but I guess this is like the fourth place that I'm like, I think it's here, and it's not. Would it be in... I used to have a bin of, quote, random ICs, but I disassembled that bin and made it more purposeful and, like, sorted them. And now I'm like, because that seems like where they would be. In fact, this is all... Here. Hi! This is all that remains of the random ICs bin. RF transformers, ADCs. What are you? MCP 401010. The bin label's max chips. I wish. An 8102. I don't know what that is. That's an oldie. 4066 op amps. Yeah, I don't think it's any of those. Touchscreen. It's like, what else was I doing with DMX recently? Here, have a nice computer. Or here, have a nice table. Computer. It's like, where would this have gone? Like I say, I will almost certainly find it about 5 minutes after, like, whenever we log off for the evening. I just didn't think that this would be the way that this evening went. Although I'm kind of excited about it. I guess. How are we doing? Yeah, I think we could also, like, whack this together on a circuit board. Inventory tracking? Oh, Chris, you overestimate my organization by 2 or 3 orders of magnitude, easily. Let's see here. Some more 3D printed truss up there. Let's see, what's back here? 120 volt connectors, ammeters, 3D printing accessories. I'm flummoxed. Where would that be? All right. Well, I might abandon that search now just because I feel like I feel like it. But I'm just thinking, like, could I simulate this circuit? I have the chips in surface mount. You know what I could do? No, I was gonna say, and it's a bad idea. Ooh, I know what I can do. So I was gonna say we could, like, bodge wire onto these, but that would be a real pain in the patook because we don't have, like, a good way of accessing the TX and RX lines on this part directly. But in the old version of Demilight, we did. So let's pull our PCBs bin. Ooh, or maybe now let's do it. I don't want to rip apart a whole old version of a Demilight. Those are classics now. Let's pull an old PCB. These are our friends from last time, right? That have there's our one that we scratched the trace off of because it was causing fire. Let's pull version 0.7. Ah, this actually, yeah, this I think will do. So here, this is actually the board that we were looking at the schematic of all nights. This is version 0.2 of the Demilight control board. And you can tell this was at the point I was ordering from Oshpark for all my boards. They come in this really classy purple. I do feel a little bad that I order all my boards now from JLC PCB. They're just cheaper, and I'm cheap, and times are tight. But Oshpark is a really cool stateside company. And if I was ever to do something that was not just like a cheapy 2-layer board, I would certainly go with them because their quality is better. I mean, like, look at how good that looks. So what I think I'm going to do is, so I have DMX input here. I have the Max 485. I'm going to bodge wire across the switch because the whole point is we shouldn't need the switch anymore. And I'm going to have to bodge in, I think it's R4 and R5. Yeah, our pull-down resistors. I'll bodge in a pull-down resistor to 5 volts on the receive side instead of putting R5 in there. And then we can test this live. Yeah, I think that's a cool idea. We'll see how it goes. I'll put this in our PCB vise and start whacking some components on here. So, and I'm going to remember to put my needlepoint tip on the iron before I turn it on for once. Let me grab my little bin of tips here. That's not the ones. Oh yeah, my needlepoint tip is just still in its little holder there. Yes, so I want, instead of the chisel tip that I've mostly been using, I'm going to use my needlepoint tip. If I had a very tiny chisel, I would use it, but I don't, so needle will work fine. Let's make sure we have all of the components, I suppose, before we dive into this. So I've actually, this is another set of bins that I've been meaning to sort, and now I'm actually kind of glad I haven't. Move the calipers out of the way here. This is the parts bin that I was used to hold all of my parts in, back when there were only really 16 parts in the Demilight project that I cared about. This bit, Nate, Nate, my hero, safety glasses, thank you. Let me get the iron heating up here, and I will grab the glasses too. This bin actually has kind of a story behind it. Max 485, yes, we have a couple of those left. We have headers for the Arduino. We don't need the switch. We have resistors. I guess that's it. We'll whack a connector on here in a little bit. I got that parts bin back in 2013 when I was the AME at Looking Glass, and a friend who was then a freelance production manager had an internship on the Big Fish tryout here in town in Chicago, and said, hey, I know you do some nerdy stuff. Big Fish is looking for the scene in the woods with the witches. It's been a while since I've seen that film. They want them to have little balls of fireflies that can do various things. Can you build us some? And I was young and was like, sure. And so ended up, I was nowhere near the level of skill that I really needed to be at, and neither, honestly, was the, like, make 10 little electronic things ecosystem as strong as it is now. But ended up building, like, 8 or 9 little balls of fireflies, and then a special one for the Queen Witch that changed colors, with little Arduino Pro Minis on headers on circuit boards. We originally were going to use, like, a 4-inch clear Christmas ornament. Let's see, I need a little bowl for these little tiny resistors before I lose them. Let me find a suitable... Oh, I know. He said, reaching off camera blindly. What could possibly go wrong? Oh, if I don't come back, it's been great. Okay. Yeah, I'll just use a little part of a J-box there. What was I talking about? Big Fish? Things that change color? I don't know. There we go. Our 10K resistors there. Oh, what we put them in. Lightning bugs. Yes, thank you. So originally the container was going to be like, they wanted them to sort of be like a clear orb. And the thought was that we could use like the 4-inch build-it-yourself Christmas ornament kits. That's like 2 halves of a clear plastic shell. But after doing some R&D, it became pretty clear that like the actors would destroy those very quickly by dropping them and throwing them across the stage and all kinds of stuff. So we found... I wish I could remember what they actually were meant to be used for. It was basically a 4-inch like silicone orb that we ended up stuffing them in. It's very similar to, actually, I don't know if this is what the product was, but what it makes me think of is for our dog now, we have a toy, which is basically the same thing, a 4-inch silicone squishy orb that has like a plastic maze inside of it. That we put her kibble in, and she can like it only got one little hole in the side, and so she has to bat it about the floor until the kibble rolls out. I wonder if that's what that product was. I honestly don't remember. It's been so long. Alrighty. It's been a while since that's not true. It's been a while since I've hand assembled one of these boards, but it's not been that long since I've had to hand place these little 0603 resistors, because so those of you, I think I put up a video about how I screwed up on Demilight version, whatever that was, 0.9.1.9, and had all of my 10K resistor positions stuffed with green LEDs, which was not ideal, at least for, trying to have a thing that works. So I've gotten pretty good with these 0603 parts in the past few months. Not great, but pretty good. All right, so that's those. So let's double check the schematic here. So R4 we want to leave pulled to ground, but R5 wants to be a 10K to 5 volts. Okay, we can do that. So R4 we can stuff sort of as designed. So that's going to be R4 here. And we'll put a little more flux on it. Alrighty. Get that tacked in there. Why no tack? Maybe I need to do a better tweeze. Oh, it's a little hard to see in the glare there. Hilarious. While I was cleaning up the shop this week, I rediscovered a couple winters ago. You know, 'cause here in Chicago, there's not a lot of sunlight in the winter, and so I bought one of those like seasonal sun lamp things, like, you know, makes the spectrum of the sunlight, and you're supposed to like set it up so it gives you the effect of having sunlight in your life, and that makes your body better or something. I don't know that I necessarily exactly believe that, but it, you know, it seemed worth a try. But I found that, and it's actually a nice, bright, diffuse 6500 Kelvin source. So I'm thinking like, oh, how can I mount that in here to be a more floody work light? Because right now I have like a par 38 LED up here, and it's nice. It's very nice and punchy, but it's very spotty. Sunlight, now is it to the day you want to check Xmas lights? Oh yeah, Chris, how is your Christmas light project going there? Quite the thing. So let's see. So this is going to need to be a 10K to 5 volts. So I think we'll do that last. So I need to bodge a wire onto that little pad there, and it's not going to be super stable. I guess these resistors over here are a place, but I think I'm just going to do a bodge wire up and over and like into one of these through hole pads because that'll be easier. So let's do our oh no! No, Max 45's not in that bin at least. I bet I have some in my PCB components box. I think I have some spares here from when I was hand assembling previous versions. Thomas says, got a sunrise alarm clock. Ooh, I've always wanted to get those sunrise alarm clocks. The trick is my wife and I don't get up at the same time. It used to be I would get up hours later because of our work schedules, and now I get up hours earlier. And so we can never, we've talked actually about getting, so on a normal, when I can be at work, on a normal day, I get up around 5:15, and she will get up around 7-ish or a little before. But in the winter, it's still so rough. We've talked about maybe I get up with my normal alarm, and she would have the sunrise alarm for trying to get her up at a later hour. Because getting up at 5:15, like there's not really sunlight then most of the year. I mean, by the time I'm commuting, there's a little in the summer months, which is really nice. But I'm sort of used to getting up in the darkness these days. Not that it's fun, but doing that every day is more plausible, I feel like. But it's pretty rough to go from getting up in the daylight to not having any of that, I think, for her very much so. Let's see. Philips Hue lights automatically turn on in the morning. Ooh, yeah. For as much as I love lighting stuff, we don't have very much intelligent home lighting in the home, which would be a fun thing. We put a few of the simple ones on our wedding registry, and I was like, I'll take charge of ordering those. I'll figure out what I want, and whatever number of year and a half later, I still haven't. Ooh, but that's just on me. It's been a bit of a busy year, as you can imagine. I think my wife is making a cocktail in the kitchen, or our dog is. I'm not. Either way, it's delightful. There we go. All right, so that's not the best alignment ever. Let's try and tidy that up just a little bit here. That's all right. All right, so we'll tack. So this is the Max 485 chip. This is our RS485 transceiver.
It's not actually a Max 485. It's probably an SP 485, which is a cheaper version, but they've all sort of standardized on this one form factor, so they're all pretty much interchangeable. Let's see. Chris has a button that slowly increases your bedroom light. Ooh, I like that. That's very cool. I'm actually gonna turn this around and do it 180 because that was working better for me. Yeah, so we'll have Winnie. Winnie can bring me a cocktail. She's been so put out. The weather was so gross the past couple of days. She hasn't been outside nearly as much as she wants to be. She loves the outdoors.
So Winnie's actually not allowed in the office / workshop. Just because, I mean, you've seen how I strip wire and things. There's just so many little bits of things. And she's so inquisitive, and she's used to eating stuff off the floor because of this like kibble roller that we have. And so there's actually a baby gate in front of the door that we use to block it off when we want to have the door open, just because it just seems safer. And she knows she's not allowed in the office. So if I'm in here and I leave the gate open for her, she won't come in, but she will just come and flop down with her nose on like the sill of the gate and just stare at me and be like, "Why are you where I can't be?" She's great. She's a very good dog. What else do I need to do here? I need to bodge across the transmit and receive lines here, so then I can receive and transmit DMX, hopefully. Let's see, I want to squeeze that. And let's see here. Got a bit of wire handy. So the whole point is that we will no longer need this enable switch. So in theory, I'm going to simulate that just by bodging a bit of wire across the pads that will be connected there. Yeah, electronic bits and dogs is not quite the thing. She's a very good girl, but she's incredibly food motivated. So we just don't feel like we could even trust to the idea of training her that she doesn't eat in the office or something is just. She's a snack hound. Yeah, and she counter surfs already, just a little, not so much, but coffee table surfs a great deal. She gets her nose on there and she'll try and have a little snack of whatever you're having. She's very sweet. We like her very much. She's also incredibly spoiled by us. She came home February 1st, I think, of this year. So she pretty much only knows a world in which we're home almost all the time. So now, I mean, she's definitely going to have separation anxiety when the world goes back to a little bit more normal. Whenever we leave, she's like, "What? I don't understand. What is this new setup where you're not petting me constantly? I don't get it." It's a good life. She's a good girl. All right, so those are bodged across now. So now I just need to whack in the pull-up resistor, and maybe there's an easier way to do that. So here's what I'm thinking. So I really just need a pull-up on the D4 line here. I guess I should yeah, D4. So I can do that by, so here, let me show you. So on the board here, as close as you can get now. Well, we can get you even closer. So here's digital pin 4. That goes to that pin, and that pad there goes straight into the max. So I can just basically use this pad to pull this whole net up to 5 volts. And I'm not going to install that pull-down resistor. That's how I'm going to do this. That's going to be much less of a pain in the butt. So let's put this back in the vise. I never readjusted my... Oh, a side view cam of me. Yeah, let's see. So if I come here, you get the full light cam. Sorry. Yeah, I figure out some way to show my the oscilloscope here. Just if we're going to keep messing with it, it seems like a useful thing. I mean, if we were being really fancy, get one of those, USB soldering microscopes, or the soldering microscopes that have an HDMI output on them, and then, oh God, put another capture device on my computer, and then throw the HDMI into that. That seems already having two capture devices between the one that does the overhead camera here and the one that does the Raspberry Pi on off. I guess I could use the one that normally does the Raspberry Pi, because that is not something I would typically be using on the nights that we're doing Demilight-y stuff. That's actually not a crazy idea. Now, I guess getting ahead of myself, because I would have to have one of those cameras. Although some of them I think have a USB functionality. You could maybe hook them directly to a computer. But that might only be for image capture and not for, like, video, which is what I'd want. All of this, like, like the overhead DSLR camera view of soldering is good, but the microscope view is just so sexy. But it seems like an extravagance. Okay, so there's our pull-up resistor on that pin. So what am I going to do now? I don't think I have headers. Yeah, I'm dead out of headers for putting the Arduino on there. So what I'm going to do, we're going to make this a dedicated testing model. I'm just going to solder in this resistor here. This Pro Mini. Oh, if I can get it off of this stale breadboard, which is a term I'm stealing, Chris. Thank you. Which printer did I say I ordered? Oh, I ordered. I should have put this in the outside hole. That's gonna be a pain. So I have a Monoprice Maker Select V2, which is their rebadge of the Wanhao i3 model, of which there are many clones. I just ordered a Prusa Mini Plus. Which is, we have a Prusa Mini at work that I have absolutely fallen in love with. It's really nice, and it's really nice. It's really nice for the price. Like I can't believe how good that printer is for the fact that it costs so little. So I have ordered one for myself because it's really good. They had a Black Friday sale where they were doing free shipping overseas, which I took advantage of. Wow, I've screwed this side up too. So that, of course, they're incredibly back ordered because they're such a nice little board. So that won't be here until, I'm just gonna redo this whole thing. That won't be here until I think late January. Orange or black? Orange. I got mine in orange. I just like, I don't know, that orange and black color scheme. That's the one our one at work is. And I kind of come to identify with that one. Yeah, we'll use a little bit more solder braid. This would be the situation. I've said before on stream, I don't really use a solder sucker, but this is the singular application for which it would be the right tool. But I have a decent amount of solder braid, so I think I can make this work. Yeah, the Mini is really just, I mean, the epitome of you plug it in and it just works. And I made the decision back when I was, make sure I line this right. Yeah, so it'll be that way. In fact, maybe I'll solder the Arduino in first so I don't screw the resistor up again. When I was first buying a 3D printer, and that was 2016, I want to say, was like, you could obviously save quite a bit of money if you assembled your own. And I decided that I wanted my hobby to be 3D printing things and not, this is going to be unfortunate if I don't have headers, because I'm not going to be able to pull this out and bodge things on. A conundrum. I guess I did not restock on headers. Let me see if I have more header pins in the PCB components bin, just for our sake. I don't know that I do. I stopped ordering the headers after a while because I stopped using the socketed Arduinos. Do totally gonna build the Prusa. Yeah, I mean, so I guess to be clear, like building a Prusa from a kit, building specifically a Prusa from a kit, I would probably do and enjoy, because I mean their quality control and their products are so good. But like any of the like order the kit from like ANET. Even back then, Creality was not super well regarded, and that's why I bought like the mono price one. Also because like the returns and the support seem to be decent. You know, we're just gonna solder this thing in, and it's gonna be fine. It's getting toward the witching hour, as it were, so I think I'm going to. View is a little strange there, huh? I'm gonna solder this in, and if I regret that, then we'll may have to call it. Ooh, I should probably put some wires on these DMX lines, though, so we can actually test it. Let's do that first. Saving Christmas money for a Prusa? Yeah, they're really nice. I have a nerd friend who just got today their i3, which I have not played with, but I would like to someday. It's in, you know, like the Prusa. So when we bought the Mini for work, it was $350 plus shipping, which is like I think $20 more than I paid for the i3 4 years ago, which is wild. Just like what you can get for $300 now is incredible. So on the Mini Plus, the new one they just released it's got some slight improvements, and also they were pretty candid, but like, you know, like everything, COVID has kind of screwed up their model a little bit. So I think that was $400. I got with free shipping, paid a little bit of import tax, and I splurged the $20 and got the filament runout sensor. So that I can, honestly, so it can tell me when it's out of filament, but honestly, more importantly, I have like half a dozen spools with that much filament on them. And I really want the ability to just like load up like, you know, the last 10 meters of a spool, run it till it's done, and have it auto pause for me, and then run the next spool of nothing until it's done, and just make a little wild multicolor print and get some of these, you know, mostly empty spools that I can't bear to throw away out of my life. I did a project for a friend printing some speaker enclosures a couple years ago, and I bought like 8 rolls of black PLA for that project, and so now I have 8 rolls of black PLA with a tiny bit of filament on that I can't use for anything else. Let's see. Chris says you can send me PETG and I'll print it for you. The Prusa Mini does great on the PETG. I know your printer is not as happy about it there, Chris. Ooh, Thomas, I'm jealous of the i3. I not having touched it, I'm jealous of you having used one. That seems very, very cool. Yeah, it seems like a really rock solid machine. I mean, the Mini, if you were setting up like a design that needs to be really rock solid and reliable, the Prusa Mini is a cantilever design, right? So it only has the upright on one side. So there is some possibility of that torquing or twisting. It's not something I've seen in really any prints that I've used, but we have a very controlled environment for it at work, which is really nice. Got 6 spools of Prusa on Friday. Oh, on Black Friday, nice. Yeah, it's really, really quite good. Yeah, we ordered the 3D printer back last fiscal year at the museum when times were a little bit rosier. And it showed up at the museum while we were shut down. And so my boss took it home and played with it for a few months, which is great. I support him. I already had a 3D printer. It was a place. And so we brought it in back when we were like trying to rev just grabbing tools, the museum up for like COVID safety. And we ended up printing like a bunch of like, so, hey, here's a button that we don't want people touching right now. Let's remove the button entirely. But what are we going to cover this weird shaped hole in this museum fixture in? Well, we could cover it with like a big flat plate. That's one option. We could do something with, like Lexan and like, custom make something, or we could 3D model it and print it in PETG in a color that mostly matches and slap it in place. We did that for a bunch of stuff. We have a bunch of interacted with the big chonky encoders that you use to like change parameters on things that are, because of the way the encoder is made, are a total pain to remove and in place. You basically have to take the entire cabinet apart with how these things are built. So my boss actually designed a 3D printed cap and shiv that sort of captured it and made it just look like a big boring white plastic box, and then put a sticker on it that says "Don't touch." So the printer has been actually incredibly useful for us. All right, what am I forgetting, y'all? I'll solder the Arduino in. I'll do the pull up, and then we'll shove it in here. I guess I should mark which one of these is these two white wires. One is ground and one is data. So we'll grab our bin O Sharpies and we'll mark this as green for ground. Do I have a bigger green? Mostly silver. All right, well that's marked enough for government work. All right, so let's tack this Arduino in, maybe in a way that I could potentially free it someday. So I really don't need that many connections. And we'll just edge it right in there. So I'm just gonna, normally I would sit this down much closer to the board, but because I want it to be maybe someday removable, we'll keep that nice and high. So now I'm going to need transmit. I'm going to need receive. I'm going to need reset. I'm going to need ground. I'm going to need, let's say, D2 and D4. Those are our control pins for the Max 485. Those are the pins, we mostly need those. Those are the ones we're testing, right? Let's attach the ground pin and reset pin on the other side for good measure. Ground and reset. We'll need our VCC pin. That's going to provide our 5 volts for our pull-up. I think that's it. And let's put our pull-up back in. So I'll need another 10K resistor. I'm not going to bother trimming it this time. So that's going to go between 5 volts and pin D4. And we'll just solder this in from the top. And then we'll shove some DMX at this thing and then see if we can program it without unplugging it from DMX. Fingers crossed. Alrighty, so to get DMX into this, I'm going to bring back, some of you may remember this old test fixture, which is two terminal blocks and 2 XLR3 connectors just on a piece of perf board, just for getting DMX wherever I need it to be. So let us grab a screwdriver and we will whack this thing in. Fingers crossed and safety glasses on. That's a t-shirt right there. I'd wear that. What did I do with my... Did I actually put my screwdriver away? That would be a first. I didn't think so. Oh, the workbench chaos. There we go. All right, so let's take this old... That's not even the right screwdriver. Let's do... There we go, that'll work. Screwdriver not for whacking, yes. All right, little flat head there. We'll get into our little terminal blocks here. Okay, so that's our old test fixture that was for injecting DC power into these things. We'll put that in the old experiments box, and we'll wire in our newly Frankensteined Arduino. So 1 ground, 2 DMX inverted, 3 DMX non-inverted. 1, 2, and 3. Okay. 1, 2. Old experiments, current experiments, and future experiments. Essentially, yeah. I've got old experiments. I've got, I guess, old. What did I call it? Old experiments, future experiments, and then all the current experiments are in like individual boxes, right? Like they actually are part of the project. Okay, okay, let's make sure I haven't screwed this up too badly. Let's just try and write our same old Blinky program to this little guy before we get too much further. So upload. I might have to reset this adapter. It's been a little while. Yep, writing, reading, good. Okay. So let us now send some DMX at this guy. How is the best way to do that with what I have here, I wonder? I have... Yeah, the beauty of Phoenix connectors. So I have made, for previous experimental purposes, a Phoenix connector to XLR adapter that has DC power injection lines on it still, though we're not going to use those for this purpose. So that's going to plug into, all these are just in parallel, so that's going to plug into whatever orientation of XLR is correct, and then this can plug into any of our current model Demilight boards to be a transmitter. Now, I say any of our current model Demilight boards as if I could see one, but given that here we go, we'll use our tester from earlier in the night. So before we plug this in, let's make sure this is still configured to send DMX. So I'm going to need to get my ISP programmer back out, hook that back up, and I guess at some point in this setup we should make sure that this will still receive DMX in this configuration. And I haven't goofed that up, but I don't think it should, although the firmware may not be quite right for that currently. So let us, here, this is just specifically just so that we're sending DMX down the line. So I don't want to use that. We're still running that RDM code where it's only sending a little burst every half a second, and I want it to just be vomiting DMX out constantly, and that's what this code will do. Great. So let us, I guess we can just see if we can upload code to the thing. That would be interesting. I guess it won't necessarily be proof positive of the signals going exactly where I think they will. So here's well, let's just try it. Let's just see if we can do an upload. Uploading. And successful. Okay, so that's good. So what occurs to me is right now, because we haven't enabled the receive line, the DMX is just stopping at the max 485 all the time, because that's what that pull-up we just installed does, which means the pull-up is doing its job. Hi, which is good. Let me put pin D4 high before we try and upload, because that will be a little bit closer to our use case here. Digital write for low. So we'll pull pin D4 low, I guess, to enable input. So the receive line will be spammed by the DMX input messages until, in theory, until we reset, and then we should still be able to program. But this will be oops, this is marked as read-only. Bah, humbug. We'll save it on that same dumb folder on the desktop as the other one. Oops. No, go back. On Scratch, we'll call this Blink2. Okay. So we'll upload that. So that should be uploading. Successful, good. So now the receive part of the serial port, the RX line, should be being spammed by DMX messages from this. I guess we should probably confirm that with the scope. At some point. If this works, we'll confirm it with the scope. But in theory, and just for the sake of changing some code, we'll make that blink twice as fast. I should still be able to upload even with DMX hitting the serial port, because that pull-up is going to put our port in the correct configuration. Yeah, even when the light's off. Well, that's a great sign. And now we're blinking twice as fast. Very cool. Let's double check that right this moment, and I'm going to put you back at something like oscilloscope view if I can, that we actually are, see what's happening on the receive line, just to give ourselves confidence that we really are interrupting the DMX. But then I think we're in a good spot, because then it's just a matter of basically, well, we'll get to the what it's then a matter of if this works, but let's give this a try first. So let's hook up our scope. I don't think we probably won't do the PCB rework on the stream tonight, just because for the sake of time. And time being, you know, I'm going strong. I took a disaster nap today, but it is getting a wee bit late into the evening, at least where I am here in Chicago. I think I'm going to bodge one more ground wire in here so I have a place to scope to. So let's unplug that. I'll just use this little scrap of wire I was using from my scope earlier. We'll just whack that in there. Get our solder back out, get our soldering iron back out. One thing, what I was going to say in that that non-tangent about, you know, what we'll do if this works is, so I'm basically will replace the ICSP header with a 6-pin header that is the same as on the Pro Mini here, but we'll still need something like an ICSP header somewhere, because when these boards come to me, I'm still going to have to burn a bootloader onto them once. And that'll be a challenge to solve. That will probably not be a full through-hole header. That'll probably just be surface mount pins, and I'll do a little pogo pin adapter that just chonks down onto them, burns the bootloader once, and then we can walk away. And all the other programming can be done over the serial port. All right, now where's my Clippy? Yes, okay. So, all right, so we try again, oscilloscope view 2. Let's see here. Alrighty, that's gonna take a second to boot up. So I can figure out where I'm gonna probe in the meantime. So I'm gonna probe the RX line, which is second from the top here. Okay, so press any key to continue. Let's see how this looks. Probably not gonna be great focus because it's awfully close. Oh, that's not awful. Kind of a wild view. This is I use this. I didn't really use this view at all. So I haven't like put any of like the borders in, like, ooh, classy borders around everything. Ooh, it's just a bunch of cameras. But, all right, so let's see. So I should have DMX coming in on the RX pin. Yes. Oh. All these tests are academic. None of them count because I did not plug in the Phoenix connector. All right, 2 steps forward, 1 step back. Maybe 2 steps back. So we plug the DMX line in, so it's actually what I guess I should have done is plug in I program it with the DMX receive code, so it was actually receiving DMX. And I would have caught this earlier, but that's all right. All right, so now let's take a step back. We are actually sending DMX into this thing now. Let's try uploading. Yep, success. And when I say actually sending DMX into this thing now, let's verify that with the scope. Yes, so that's our DMX input. And so now when I hit upload, we should see it drop to nothing. Then we'll see a brief burst as it uploads the new code, and then we should be back to DMX. So let's see if that's true. So upload, disable, uploading, and DMX. Great. Well, that's awesome. That's such a much more simple change than I was expecting to have to make in the circuit board. Basically just changing that pull down resistor to be a pull up resistor, which is awesome. So we'll do that for version 0.95. So the things that I am anticipating for version 0.95, well, for future versions, let's say, because we'll see how the timeline is, changing the programming interface to one of these, 6-pin FTDI interfaces. I think having a USB connector on the boards is still a long-term goal, but like baby steps. Other goals for future improvements, and I'm probably saying this out loud because I need to put this section on the build instructions on the website, like so people know what might be changing, include I want to rework the hanging hardware mechanism. Right now, it's threaded inserts into the bottom, and I said before, I don't find those terribly easy to work with. So I have half an idea about a 3D, changing the 3D print design so that there's a hook and lock that goes into the body of the print, and then there's a hook that obviously is the hanging part. Some kind of notch and hook setup that I think will be more flexible, but that's sort of a half-baked idea. So hanging hardware, programmability, some way to mechanically attach this header. I know I keep pushing this part back. This is just stuck on here with sticky tack right now. It's a little thing, and maybe there's a clever way to have it interlock with this lid or this bottom part or something, but that's just a little aesthetic part. Yeah, those are the sort of major change. And then feature improvements will come down the road, thinking about RGB color, thinking about more pads, whether surface mount or through hole for people who want to add their own external devices. We have a microcontroller with 20 digital I/O and we're only using 5 of them, so giving access on the bottom of the boards so that obviously I've been experimenting with using this for other purposes as a transmitter. It'd be a lot more easy to experiment with if it, in addition to just some servo pads, maybe there's some surface mount pads in the bottom you can tack to, so if you wanted to turn this into a little board that does, that we could attach buttons and switches or outputs or something just to this board as it is and not spin a whole new board. Just to make it a little bit more flexible because pads and traces are free. But that's what my mind goes to in the future. But yeah, this was a really successful experiment. I'm actually really glad we went down this rabbit hole so we could see how the reset line actually works with a DTR on the programmer. But I'm also really gratified that the ultimate solution is going to be just a resistor change on the circuit board, because that's a change that's much more likely to go well. So I'm stoked about that. Yeah, next week, in what would normally be the Python programming class week, I'm actually going to be, because it's the holidays and things are busy and that's going to be a lot to get together, I'm going to do a little instructional stream on Fusion 360. Partly because it's fun and I use it a lot and I enjoy it, and I have some friends who have been thinking about 3D printing, or maybe are getting a 3D printer for Christmas or thinking about getting a 3D printer for Christmas, and I think Fusion is a great tool for 3D modeling, for 3D printing specifically. Just the way that its workflow works as a design for manufacturing tool, I think is really good. So if you're interested in Fusion or how it works, whether if you're 3D modeling things for printing, or just honestly just making 3D models of things. One of the things we did when we moved in is I made a 3D model of this room and used it to plan out where all the shelves and brackets and heights go. That was super useful. I mean, none of it's 3D printed, of course, but the ability to accurately and easily model something in 3D, kind of cool. So that'll be next Sunday night at 7 p.m. Right here, and then the week after will be the Sunday after Christmas. So we'll see what scheduling looks like. Maybe we take a week off. Maybe we're right here at 7 p.m. Either way, if you subscribe. I'm not a YouTuber. I can't do it. But if you subscribe, you'll get notified of it, and you can come join us back here Sunday nights at 7 p.m. We do all kinds of fun stuff, as you all know, all you good nerds out there. If you want more info on the Demilight project, jeff.glass/Demilight. It's down in this corner. If you have questions in the meantime, or if you do cool things, Thomas, if you make more progress on your moving light, Chris, if you have, I someday when it's safe to do so, I want a tour of your Christmas setup. Find me on Twitter. At Jeffers Glass is the easiest way to find me, and I'll see it there, and we'll get stuff going. Thanks, nerds. Thanks for hanging out with us tonight. This was, as always on these streams, on these Demilight streams especially, it's I think I'm gonna try X, and then we hit 17 pinball bumpers along the way and go in a different direction. But that's just how workbench works. I feel so I feel very, it's cool to just share that process with other people out there in the universe, you good nerds. I hope you're staying safe out there. I hope you're washing your hands, wearing masks, keeping safe. There's light at the end of the tunnel in this thing. Keep coming back. We'll keep making more. There's little lights on the end of the tunnel, I guess, and we'll make it through this thing together. Thank you so much, and I will see you soon. Thanks all.